Tranquility Base here. The Eagle has landed.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
ABC News presents Footsteps on the Moon, the flight of Apollo 11.
Good morning, ladies and gentlemen. I'm Frank Reynolds at ABC Space Headquarters in New York. It is July 16th, 1969, and we are all about to witness the fulfillment of that promise that President Kennedy made at Rice University Stadium in Texas on September 12th, 1962. The moon that still has not set in some parts of our world has only a few more days of what you might call untrammeled history. These three men are about to embark on certainly one of history's most glorious adventures. Commander Neil Armstrong, Lunar Module pilot Buzz Aldrin, and Command Module pilot Mike Collins. Armstrong and Collins have already entered their command module, and Buzz Aldrin will be entering to join them in a few moments to begin this epic journey, and we shall all see it. ABC Science Editor Jules Bergman is at the Cape. There has been a minor difficulty developed there at the Cape, and let's get a report from Jules now on just what is being done. Good morning, Jules.
Good morning, Frank. We're at T-minus 2 hours and 28 minutes into the scheduled launch of Apollo 11 at 9:32 a.m. Eastern Daylight Time, and the countdown has been going spectacularly until about 10 minutes ago, just before Neil Armstrong, Mike Collins, and Buzz Aldrin started to get into the cabin of Apollo 11. And then a slight leak developed in a valve system that replenishes the liquid hydrogen for the third stage of the Saturn V, the S4B stage. The valve in question is not on the spacecraft itself, but on GSE, or ground support equipment. It's the same valve, the very same valve, by the way, that leaked back on Apollo 10. Everything else here, Frank, is holding up very well. There's a forecast of clouds at 15,000 feet. As we look back to pad 39, right directly behind our ABC News Space Headquarters here at the Cape, you can see the clouds over the ocean. They haven't yet truly developed over the land area, and if it stays this way, everyone in the country and millions of people gathered around Central Florida will get a spectacular eyewitness view of Apollo 11 and the Saturn V lifting off. As it is now, there's a light layer of cirrus clouds at about 15 to 20,000 feet over the Cape. They could cause some interference with visual viewing, but not with the launch itself. The launch limits have gone down really much, if you will, on this fourth launch, we should say, of the Saturn V, fourth manned launch, fifth unmanned. As of now, the weather is good, the countdown going well, except for this liquid hydrogen leak, which has to be fixed, and there's no reason to think we won't lift off at 9:32 a.m. Eastern Daylight Time as scheduled. That's the story, Frank.
The astronauts of Apollo 11 awoke early today and began their ritual-like preparations for this blast-off to the moon. One of their doctors, as I told you earlier, said they appear rested, fit as a fiddle, and ready to go. They actually had about 8 hours of sound sleep, which is probably more than a good many other people who were preparing for this launch today. They had a big breakfast of scrambled eggs, steak, toast, coffee, and orange juice. And for a film report on their final meal on Earth before blasting off, here's Jules Bergman at the Cape.
Crew astronauts Armstrong, Aldrin, and Collins were awakened at 4:15 a.m. this morning, just about 3 hours ago, after having gone to bed about 9:20 last night, and immediately after a quick medical, had the traditional astronauts' breakfast of steak and eggs. There's Buzz Aldrin, the lunar module pilot. We saw Mike Collins a moment ago. Spacecraft Commander Neil Armstrong, who'll be 39 on August 5th, just a few days from now, led by security guards, greeting a farewell as they get into the transfer van for the 3.5-mile ride to pad 39A. Neil Armstrong leading the way, then Mike Collins in, and finally Buzz Aldrin.
We're back at ABC Space Headquarters in New York, awaiting the still scheduled launch at 9:32 Eastern Daylight Time this morning of Apollo 11. The commander of the mission is 38-year-old Neil Armstrong, the only civilian among the three-man crew, and of course the man scheduled to take the first actual step on the moon. The pilot of the lunar landing module is Edwin Aldrin Jr., 39 years old, and an Air Force colonel. 38-year-old Michael Collins, a lieutenant colonel in the Air Force, is the pilot of the command module. It will be his job to circle the moon while Armstrong and Aldrin are down on its surface. Jules, did you have any difficulty getting out to the Cape this morning?
Frank, we had no difficulty, but we practically didn't get to sleep at all last night just to be sure we wouldn't have any difficulty. The shot we're looking at from the helicopter now is over Highway A1A, the main north-south road along the Atlantic, and we're looking at the beach just below the South Gate, the old Gate 1 of the Cape where we came in this morning. You know, the drama may be here at Pad 39 and on the moon this Sunday, that unforgettable drama, but it's somehow, for me, also on the roads around this spit of land which Spanish explorers 352 years ago landed on and called Canaveral, for the fields of sugar cane. That's what Canaveral means in Spanish, cane fields. The fields of sugar cane they found growing here. We passed 10,000 odd cars, what we've guesstimated, parked around the Gate 1 area at 4 a.m. when we got here, cars from every state, with little kids staring wide-eyed at the Saturn V glowing in the huge xenon spotlights 15 miles away. And we saw teenagers with telescopes. It was the very same road we came over 8 long years ago, 21 manned space flights ago, when we came out at just about the same hour to cover Alan Shepard's 15-minute suborbital hop, America's first manned space flight. Americans cared then, I think, and they care now. And it was a very moving scene for me because, well, we were tired. They were tired. They'd been up all night. All those thousands of people who we see now in daylight in those cars parked along the road that our live helicopter is showing us. Indeed, the helicopter pilot this morning, Bob Lockrow is his name, was the same man who used to fly us here with the very first film switches we did on flights and the very first live things. There's good luck Apollo 11 engraved in the sand. All going very smoothly here with the count. Among the distinguished visitors here this morning, along with Vice President Spiro Agnew, is the former President Lyndon Johnson. There's our live picture from the VIP stands on the other side of the VAB and Launch Control Center. Behind the former president is former NASA Administrator James Webb, sitting in the picture, and many other dignitaries gathered there. Some 8,000 dignitaries in all invited by the space agency as guests to be at this launch. And there's Mrs. Johnson being greeted with the former president.
42 minutes and 44 seconds away from liftoff now of Apollo 11, which is about the size of a United States Navy destroyer, as we pointed out to you a bit earlier. It stands higher than the Statue of Liberty, and it is the most sophisticated space vehicle in the world today. It is made up of 5 separate parts. Jules Bergman has the story on it.
Apollo 11 contains the lunar module, or LEM, which will weigh more than 32,000 pounds at launch time. The command module serves as a flight operations center and living quarters for the astronauts. After the third stage rocket sends Apollo 11 toward the moon, the onboard service module engine will be used to put the astronauts into lunar orbit and later to return them home to Earth. The total payload, nearly 100,000 pounds, rests on a Saturn V rocket. The first stage generates 7.5 million pounds of thrust at liftoff. The second stage will carry the Apollo spacecraft and astronauts to an altitude of 100 miles. And then the third stage breaks Apollo 11 out of Earth orbit and propels the astronauts toward the moon. And this is what Eagle, the lunar module on Apollo 11, will look like after its legs are, its gear is put down after translunar flight has begun and as it heads toward the moon. In addition to this black and white covering, of course, it's covered by gold and black thermal foil, if you will, mylar foil, and black foil to protect it from heating as it heads around into lunar orbit and then down toward its descent on the moon. But essentially, that's what the vehicle looks like, a very ungainly machine. The astronauts still call it a thin, light-walled flying machine, a thin, light-walled structure, but it has proven to be one heck of a good flying machine on 2 flights now, Apollo 9 and Apollo 10. Launch control is telling us now that things are proceeding very smoothly with the fueling and with topping off the liquid oxygen in the S1C, the Saturn main stage, all going very smoothly at T-minus 40 minutes, and we're lifting off at 9:32 a.m. Eastern Daylight Time as of now, everything proceeding very smoothly toward that pre-calculated liftoff time.
2 minutes, 10 seconds, and counting. The target for the Apollo 11 astronauts, the moon at liftoff, will be at a distance of 218,096 miles away. We've just passed the 2-minute mark in the countdown. T-minus 1 minute, 54 seconds, and counting. Our status board indicates that the oxidizer tanks in the second and third stages now have pressurized. We continue to build up pressure in all 3 stages here at the last minute to prepare it for liftoff. T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land of the first men on the moon. All indications coming in to the control center at this time indicate we are go. 1 minute, 25 seconds and counting. Our status board indicates the third stage completely pressurized. 80-second mark has now been passed. We'll go on full internal power at the 50-second mark in the countdown. Guidance system goes on internal at 17 seconds, leading up to the ignition sequence at 8.9 seconds. We're approaching the 60-second mark on the Apollo 11 mission. T-minus 60 seconds and counting. We passed T-minus 60. 55 seconds and counting. Neil Armstrong just reported back. It's been a real smooth countdown. We passed the 50-second mark. Power transfer is complete. We're on internal power with the launch vehicle at this time. 40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
We got a roll program.
Neil Armstrong reporting their roll and pitch program, which puts Apollo 11 on a proper heading.
Slowly, but gathering speed. Going beautifully, burning hot.
Plus 30 seconds.
Roll complete and the pitch is programmed. One Bravo
is a abort control mode. Altitude's 2 miles.
Houston, you're good at 1 minute.
Downrange 1 mile, altitude 4 miles now. Velocity 2,195 feet per second.
She's going beautifully.
We're through the region of maximum dynamic pressure now.
Apollo 11, 42,000 feet.
17 miles an hour, head range 12 miles high, velocity 4,000 feet per second.
Stand by on mode 1 Charlie. Mark, mode 1 Charlie. 1 Charlie.
Cliff Charlesworth taking a staging status.
This is Houston, you are go for staging. Inboard cutoff.
Inboard engines out.
I'm inboard cutoff.
inboard cutoff exactly on schedule. Apollo 11 now 3,000 miles, now doing 3,650 miles an hour.
Downrange 35 miles, 30 miles high. Standing by for the outboard engine cut down now.
Staging. And ignition.
Armstrong reporting staging and ignition. The first stage engines have burned out exactly on schedule. The second stage engines have lit off.
Houston, thrust is go. All engines, you're looking good. All right, Roger. You're loud and clear, Houston.
41
3
miles.
minutes downrange 70 miles, 43 miles high, velocity 9,300 feet per second.
We got skirt step. Roger, we confirm skirt step.
Apollo 11 going a little faster than expected, but perfectly within
Neil
limits.
Armstrong confirming both the engine skirt separation and the launch escape tower separation.
Houston, be advised the visual is go today. This is Houston, Roger out. Yeah, they finally gave me a window to look out. Houston, your guidance is converged. You're looking good.
Downrange 140 miles, altitude 62 miles, velocity 10,300 feet per second.
11 Houston, you are go at 4 minutes. Roger.
Still in sight from our long-range cameras, burning hot, straight and true all the way toward a moon 218,000 miles distant. A moment many Americans, many people never believed could happen or would happen.
190 miles downrange now, 72 miles high, velocity 11,000 feet per second.
And the first major hurdles have been passed for Apollo 11. All going very, very well. The first minutes of a 195-hour-long flight, ticking off almost without tension, almost like a regular airliner takeoff, but for the thunderous roar, the flame of the Saturn V.
Booster says it's looking good at 5 minutes.
11 Houston, you are go at 5 minutes. Roger, Apollo 11, go.
We're hearing Neil Armstrong live, reporting back to Booster Control, Capcom in Mission Control.
270 miles, altitude 82 miles, velocity 12,472 feet per second.
Fly to S4B to COI capability. Okay.
That's 9,000 miles an hour.
S4B to COI capability.
That's 9,000 miles an hour. Confirmation that the
Apollo 11 could now get into orbit using the S4B if necessary.
In your living room. Oh, thank you. We're coming through beautifully, too.
very clear communications this morning, very clear air-to-ground from Apollo 11. That's Capcom Bruce McCandless you hear talking from Houston Mission Control. And occasionally Flight Director Cliff Charlesworth in the background. And down...
Everyone's reporting go here in the control center.
So it's 6 minutes, starting to get motors.
And our long-range...
Roger 11, your go from the ground at 6 minutes.
Our long-range cameras have lost the picture finally. Our cameras are now at pad 39, viewing that water deluge or dousing system we told you about. Hundreds of thousands of gallons of water, saving the pad from being all but wiped out by the heat and the flame. The water still going, still keeping cool. Our animated view now showing us what's happening up there at 6 minutes and 35 seconds into the flight of Apollo 11.
Between the second stage and the third stage, the fuel uncovers a sensor starting that sequence.
We're coming up almost to the point where the second stage S2 rockets will burn out.
Covered at 8 minutes 17 seconds with outboard engine cut off 9 minutes 11 seconds on the second stage.
Apollo 11's go at 7 minutes. 11, this is Houston. Roger, your go from the ground at 7 minutes. Level sense arm at 8+17. Outboard cut off at 9+11. Roger.
Very close to
Downrange
nominal figures.
530 miles, altitude 95 miles, velocity 17,358 feet per second.
Apollo 11 has almost reached orbital velocity now. It'll require another minute of burn of the S2 second stage. President Johnson in the VIP stands with Lady Bird Johnson, obviously relaxed, happy at the way the launch went, and Vice President Agnew next to the
At
president.
7 minutes, 41 seconds.
Roger, we confirm.
Inboard engines are out on the second stage as planned.
Inboard engine burnout exactly on schedule at 7 minutes 40 seconds. Apollo 11 now about 3 minutes away from going into Earth's orbit over mid-Atlantic.
Apollo 11, go on all sources.
New York, go at 8 minutes.
I've just built the mixture ratio ship.
And galloping
We got
along.
PU shift down here, too.
Apollo 11 galloping along now at more than 12,500 miles an hour.
United States Board, these thunderstorms downrange is about all.
That was Neil Armstrong. We couldn't make out what he said.
11, this is Houston. You are go for staging. Over.
Understand, go for staging.
Stand by for mode 4 capability.
Mode 4.
Mark, mode 4 capability.
Mode 4 and Apollo 11 could get into orbit using the service propulsion system now. Altitude is 100 miles, downrange 883 miles. Outboard engine cut off. And ignition.
Ignition confirmed. Thrusters go, 11.
And we have a good third stage now.
Third stage ignition on schedule, speed building up just the way it should. Looking very, very good.
Velocity 23,128 feet per second. Downrange 1,000 miles, altitude 101 miles.
Apollo 11, this is Houston. At 10 minutes, you are go.
Roger, 11, go. Capcom Bruce McCandless giving the reports here from the control center.
A relaxed Neil Armstrong saying, "Ah, Roger, we're go."
Apollo 11, this is Houston. Predicted cutoff at 11 plus 42. Over.
1142, Roger. Downrange 1,175 miles. Velocity 24,190 feet per second. Altitude 102 nautical miles. Apollo 11 still go on all sources.
Apollo 11, this is Houston. You are go at 11.
And ticking away the last 2 seconds.
We're predicting third stage shutdown at 11 minutes 42 seconds.
And Apollo 11 is just about ready to go into orbit in a few seconds from now.
Velocity 25,254 feet per second. Downrange 1,400 miles now. Altitude 102.8 nautical miles. Shutdown. Shutdown right on time. 1.4 by 103.6.
Roger, shut down, and we copy 101.4 by 103.6.
And Apollo 11 is in orbit. Scratchy.
Apollo 11, this is Houston. You are confirmed to go for orbit.
When the third stage is fired, the astronauts will then be inserted into an Earth parking orbit.
the guidance system has already computed the trajectory needed to intercept the moon. The confirmation of that trajectory or course will be relayed by Houston to the astronauts. 2 hours and 40 minutes after launch over the Pacific, the third stage engine will be restarted, and when an escape velocity of nearly 25,000 miles per hour is reached, Apollo 11 will be injected into a translunar trajectory. Soon after, the panels of the spacecraft's lunar module adapter are jettisoned. The Apollo Command and Service Module then separates from the booster. The astronauts start the docking maneuver, rotating Apollo 180 degrees, and then, using their small thruster rockets, dock with the LEM. The third stage will be jettisoned when the docking maneuver is completed about 2 hours after translunar injection. The astronauts, using star sightings backed up by mission control, guidance radar, and computers, then work up the data to make mid-course corrections and set their course to intercept the moon 3 days later. Depending on how accurate the rocket engine burns to get away from Earth, none or as many as 3 mid-course corrections may be needed. Apollo's speed decreases from 25,000 to less than 4,000 miles per hour en route. Then, near the moon, as lunar gravity begins to exert its influence, the speed of the spacecraft increases up to 6,000 miles per hour. Apollo 11 is in a free return trajectory, which will carry it around the moon and back to Earth for recovery if problems have developed. But if all has gone well, Apollo 11's onboard service module engine will be fired and the spacecraft will be placed into lunar orbit. Because of the danger of mechanical failure, all of the systems can be overridden by the astronauts if the automatic systems aren't working perfectly. 81 hours into the flight, Armstrong and Aldrin transfer into the lunar module for the second time, completing their checkout of the lunar landing spacecraft. They remove the docking probe and drogue from the tunnel connecting the command and lunar modules and equalize the pressure in both vehicles. The lunar module pilot then floats through the docking tunnel overhead and into the LEM. One of the first tasks for the lunar module pilot is to activate the LEM's environmental control system and to change his suit connections to the LEM's umbilicals. Now, today the moon is the target, and we're going to get the word on that TLI burn coming up in just a moment now from Mission Control. And we're now 14 seconds away from TLI burn. Mission Control is counting down. There's ignition. There's the word from Mission Control. Ignition over the South Pacific for the translunar insertion burn.
We confirm ignition, and the thrusters go.
Thrust is built up to get them headed up to escape velocity speed of 25,000 miles an hour. The burn took place over the southwestern Pacific 2 hours and 24 minutes into the flight of Apollo 11.
Guidance looking good.
Let's go to Mission Control now for the talk down to the separation maneuver.
This is Houston, we copy.
Capcom McCandless saying he copied, but we very faint transmission. Let's see if we can pick it up now.
We confirm the separation here on the ground.
Separation confirmed. The third major hurdle of the flight accomplished. Next, that docking and extraction of the LEM.
All right, we now have a picture from Apollo 11, so let's go to Houston for the conversation between the spacecraft and Houston, and we'll see these pictures. There's the Earth.
The Earth from 130,000 nautical, or about 149,000 statute miles.
Roger, you're seeing Earth as we see it at our left-hand window, just a little more than a half Earth. We're looking at the eastern Pacific Ocean. In the north half of the top half of the screen, we can see North America, Alaska, United States, Canada, Mexico, and Central America. South America becomes invisible just off beyond the terminator or inside the shadow. We can see the oceans with a definite blue cast, see white bands of major cloud formations across the Earth, and can see coastlines. Pick out the western U.S., San Joaquin Valley, the Sierra Mountain Range, the peninsula of Baja California, and can see some cloud formations over southeastern U.S. There's one definite mild storm southwest of Alaska. Looks like about 500 to 1,000 miles. And another very minor storm showing the south end of the screen near the, a long way south of the equator, probably 45 degrees or more south latitude.
So you're saying, Cliff Charlesworth, that
we can still see the Earth through the left window, and it appears that we can see a floodlight off to the left, either that or some sun shafting through the hatch window.
Almost looks like two Earths.
It's floodlight. Now we're coming in. Can't quite make out who that had. That's Big Mike Collins there.
Well, you got a little bit of... Yeah, hello there, sports fans. You got a little bit of me, plus Neil's in the center couch, and Buzz is doing the camera work this time.
Roger, it's a little dark now, 11. Maybe a bigger f-stop might help.
Yeah, that didn't work.
It's getting a lot better now, 11. Mikey coming in 5 by. Got a good...
Well, I put on a coat and tie if I'd known about this ahead of time.
Is Buzz holding your cue cards for you over?
Cue cards have a no. We have... We are very comfortable up here, though. We do have a happy home. There's plenty of room for the three of us, and I think we're all learning to find our favorite little corner to sit in. The zero G is very comfortable, but after a while you get to the point where you sort of get tired of rattling around and banging off the ceiling and the floor and the side, so you tend to find a little corner somewhere and put your knees up or something like that to wedge yourself in, and that seems more at home.
Roger, looks like Neil is coming in 5 by there. 11, Mike, see you in the background. The definition is really outstanding. The colors are good. It's a real good picture we're getting here of the Commander Armstrong.
Yeah, Neil's standing on his head again. He's trying to make me nervous.
Roger.
He's disappearing up into the tunnel, of course, as he would going into the lunar module, only backwards.
Roger, we can see portions of the LAP now, the systems test meter panel in the lower part of the picture. We did have it anyway.
Okay, and then directly behind his head are our optical instruments, the sextant and the telescope that we use to take sightings with.
Roger, copy, and we see the disk flashing with a 651. In fact, we can read registers 1 and 2 quite clearly.
That's the computer
Yeah, the old
keyboard
gain
readout.
angles telling us which way the Earth is.
Right. Read the numbers.
Copy. That's a beautiful picture. Clarity is outstanding.
We can also give you the time of day in our system of mission elapsed time. Elapsed time, 34 hours, 16 minutes, and 15 seconds.
Roger. Can you see that clearly enough, Charlie? Roger, Apollo 11. We can see it counting up every second. We got 3417.02 now. Okay, back to the high gain angles. Roger. Swing amp. Now we've amputated those.
Best quality picture we've ever seen from the inside of a spacecraft.
It has to be able to read those numbers like that. It's like a tote board of the racetrack.
Even if it is their computer display keyboard or disk key readout.
11, Houston, we have a beautiful rainbow there, and as you move the camera around, that looks like the star chart coming into view now, over. Yeah, those are Buzz's two star charts that he is using right now as sunshades over the right-hand window, window number 5. Roger, we see the sun shining in through it behind him and plotting out the the ecliptic plane and the stars that you're using for the navigation. You're right. He doesn't really need the charts. He's got them memorized. It's just for show. We copy. Well, we're pointing up in this direction. We see out our side windows the sun going by, and of course out one of our windows right now we've got the Earth. Now right behind my window, of course, we have the sun, because the sun is illuminating the star chart that we see. This line represents the ecliptic plane, and these lines, vertical lines, represent our reference system that the spacecraft is using at this time. As we approach the moon will gradually grow larger and larger in size, and eventually it will be in eclipse. It will be eclipsing the sun as we go behind it as we approach the lunar orbit insertion maneuver. Roger, 11. Could you attempt a little bit better focus there, 11, over?
Like Mike Collins is moving the camera around the inside of the spacecraft again, back to Buzz Aldrin's star charts.
Now, Aldrin's the only one we haven't seen. He was talking just a moment ago, but we haven't seen him yet.
So part of the smooth pate of his semi-bald head.
11, Houston, that's a lot better on the star chart now. We can make out the ecliptic plane and the planets and the sun and the moon as they're drawn at various places throughout the ecliptic plane, over. Okay, Charlie.
There's Aldrin.
Slightly out of focus shot, and a little audio breakup beginning.
If we can get some of the wires untangled here, we'll give you a demonstration of how easy push-ups are up here. 11, Roger. Good view of Buzz there.
One of the reasons these pictures are such good quality is they're using a small floodlight inside the cabin to help illuminate their faces and the instruments.
When it gets pretty hard doing it that way, we just roll over and do it the other way. Right, we copy. Couldn't figure out whether that was a chin-up or a push-up. Just take your choice, I guess.
Buzz Aldrin going through a complete roll now in weightlessness. floating his way forward in the cabin from the lower equipment bay.
Here's a champion pole
Well,
vault.
looks like it's probably almost your dinner time down there, Earth. We'll show you our food cabinet here in a second. 11, roger.
You know, Frank, in weightlessness, even I could be a champion acrobat. It doesn't take a Buzz Aldrin. And now we're looking in the left-hand lower equipment bay where the food is stored and prepared. That's probably Mike
11,
Collins.
Houston, we see a box full of goodies there, over.
They've got
Oh, we really have them, Charlie. We got all kinds of good stuff. We've got coffee up here in the upper left and various breakfast items, bacon in little small bites, and beverages like fruit drink. And over in the center part, we have all kinds of things. Let me pull one out here and see what it is. Right. Would you believe you're looking at chicken stew here? All you have to do is 3 ounces of hot water for 5 or 10 minutes. Now we get our hot water out of a little spigot up here with a filter on it that filters any gases that may be in the drinking water out. And we just stick the end of this little tube in the end of the spigot and pull the trigger 3 times for 3 ounces of hot water, and then mush it up and slice the end off it. And there you go, beautiful chicken stew. Sounds delicious.
And that's their little emergency flashlight.
Yeah, the food so far has been very good. We couldn't be happier with it. Roger. Flashlight a second. The surgeons are saying thank you there for that. And it is sort of down in a dark corner, so we have a flashlight here to help us see things. And if I can let go of it carefully, it'll just hold itself right where it is. Roger. As long as you disturb it, will. Apollo 11, Houston, that's a pretty good demonstration. You started out really stable there, Mike. Well, the problem is no matter how carefully you let go, you bump it just a tiny little bit, set it in motion, and once in motion, there she goes. Try that again. It looks fairly stable now with slow rotation.
A little 13-pound portable TV camera shooting these pictures handheld by the astronauts themselves. Now more than 130,000 miles out in space.
I sent their compliments to the chef this afternoon about the salmon salad, which should make salmon fishermen
Well,
very
so much
happy.
for the food department. I'm going to close up the store down here. Roger, we copy. Charlie, we checked out the cable lengths, and we're thinking we might want to see if we can take the TV into the LEM with us tomorrow for part of the time. Over. Roger, good show. We'd like to see it if it'll reach that far. Over. We'll give it a try. Roger.
And we're seeing Mike Collins closing up the food locker. That was Buzz Aldrin we heard, saying they might take the camera up into the lunar module tomorrow at 56 hours into the flight when they check it out for the first time.
With a clear definition there of Collins' face.
The camera has been clamped on using some small hand clamps they use for their still picture cameras and motion picture cameras.
Now, where I sleep is down underneath this couch. Houston, Roger.
And Mike Collins is apparently about to show us a demonstration of his sleep station.
Slowly sinking into the sack there. Yeah, it's really comfortable.
morning.
I got to give Buzzy's flashlight back.
They carry some 7 of those little emergency flashlights, Frank, which are really meant as survival flashlights in case they come down on the water and are stranded at sea at night. But they end up using them for everything.
Well, the one question that is raised most often, over and over again, talk about redundancy, is why go to the moon? Well, for scientists, of course, the answer is obvious. They feel that the unexplored moon, thus far unexplored, will tell us many things about our Earth that we cannot find out by studying the Earth itself. In making it a comfortable place to live here, we have more or less wiped out its early history. One of our guests throughout our Apollo 11 coverage, we've already heard from him today, is Dr. Robert Jastrow, who is director of the Goddard Institute for Space Studies at Columbia University. We put the question to Dr. Goddard, why go to the moon?
The moon is a poor piece of real estate, and probably lifeless. But for precisely that reason, it is scientifically invaluable. We would like to know what conditions were on the Earth in the first billion years of its history, about 3.5 billion years ago, when life appeared on this planet according to the fossil record. We'd like to know how the solar system was formed and how the Earth itself was formed. These are things that we would like to know in order to understand whether we are probably unique in our human experience in this part of the world or this part of the universe, or whether what we are experiencing on our planet has been gone through many times in many places. Now, unfortunately, this early history of the Earth has been wiped out by the very factors on our planet that make it such a comfortable place to live in. We have running water, and we have winds, atmosphere. They erode all of the record of our past. We have mountain building, which creates the beautiful continents, but it also wears out and turns over and churns around the record or the rocks that were laid down here when the Earth was a young planet. The very life that we have has removed the traces of its own origins. On the moon, however, which we think is probably lifeless, there's no atmosphere, there's no running water at the present time, and we think that the record of its past is infinitely better preserved than it is on the Earth. Just looking at a picture of the moon such as this one shows you countless craters, the scars of meteorite impacts that have occurred throughout the moon's history. There are 100,000 of them or so visible in a telescope on the front face of the moon alone. Now, these craters, which were probably formed by meteorite impacts, have also, or must also, have occurred on the Earth. The same bombardment by meteorites must have occurred. There are, however, very few remains of those craters left. One of the few remaining is the Arizona crater, a crater 4,000 feet across that you can see when you fly, let's say, from New York to Los Angeles in a jet. This is one of 20 or so craters that are still visible on the face of the Earth. The other hundreds of thousands of millions have been worn away and turned over and buried. Because of the fact that these craters still remain on the moon but are gone from the Earth, we are pretty confident that the moon's surface goes back farther than the surface of the Earth. Just as a digression, by the way, I'd like to mention that there was a big dispute among scientists until recently over whether the craters on the moon were volcanic or meteorite impact. I think most people believe that while some of these craters are volcanoes, the majority of them are meteorite impacts. And the reason they believe that can be demonstrated in the studio. When a meteorite comes into the surface of the moon, it has so high a speed that its energy per pound is 5 or 10 times that of TNT. It drills a clean hole in the surface of the moon and buries itself underground, driving a plug of moon rock ahead of it at such a great rate that the plug of rock is compressed and heated to a gas, a vaporized rock gas. When the meteorite comes to rest, then this plug of hot gas explodes, ejecting all the material above it and forming a crater, something like a bomb crater. Bomb craters have exactly the same size and shape as most craters on the moon, and we think, therefore, that moon craters are bomb craters. I can't explode a bomb in the studio, but I have buried a firecracker in a bin of sand to produce a small crater of the kind you can see in surveyor photographs of the moon, and a crater which in minuscule form has the dimensions, the scaling, and the shape of lunar craters and bomb craters on the Earth. That was very satisfactory because it shows not only the characteristic conical shape of many lunar craters, but it even shows the lip that forms around them and the bits of debris, in this case they're chunks of flour, that litter the field, and it shows these rays, these radiating lines of light material by which scientists always are able to recognize freshly formed new craters on the moon. In particular, this little explosion crater looks just like large bomb craters and like most lunar craters. So I think there's no doubt what the origin of lunar craters, of many of them at least, is. That doesn't exclude the fact that some craters are volcanic, but that's another story, that's another matter. Now, there's a very interesting consequence of the fact that many craters on the moon are explosion craters formed by meteorites. I have a picture of a 500-foot crater which happens to be in the Ocean of Storms on the west limb of the moon. It's actually in the mouth of the face of the man in the moon when you look at him in the sky. And you see in this crater a littering of the field, of the ocean surface around it, with chunks of rock, some of them 10, some of them 20, 30 feet in diameter. The significance is that when we land on the moon, in each of our landings, although the exploration or the region explored is quite small, perhaps the size of a garden plot in the first landings, we will probably find on that garden plot an accumulation of debris, as shown in the next photograph, the Surveyor photograph, taken of a region on the moon similar to the regions in which the landings are occurring. We will find an accumulation of debris, as you see in this picture of the moon surface, representing rocks hurled out of craters all over the moon, rocks from all ages of the moon's past, all depths, all places. An excellent sample of the whole moon acquired from the exploration of one small territory. At least we will be finding these things, this variety, if we're lucky. What will we do with these samples of rocks when we get them? Well, the key question always, I think, in discussing the scientific interest of the moon is, does any part of its surface go back to the missing billion years of the solar system's history and the time in which life appeared on our own planet, or does it not? How old is the surface of the moon? There's much controversy on that question. Some of us hope or expect that parts of the moon do go back to that first missing billion years. And partly with this motivation, among the experiments performed on the lunar rocks as soon as they are let out of quarantine in Houston, the single largest block, about 30 or 40 experimental groups here and abroad, will be concerned with dating these rocks. They're dated radioactively using the fact that all rocks on the Earth, and we're pretty sure on the moon, contain trace amounts of radioactive substances such as uranium. They're present in very, very minute traces, I think a few parts per million, but nonetheless enough so that the radioactivity can be detected if one has a Geiger counter. I have one here. It's connected to an amplifier and a microphone so that it gives a visible click every time it's triggered by the passage of an energetic particle through it. You can hear it click once in a while as I speak because a cosmic ray has passed through it. I also have a piece of rock which contains not invisible amounts, but in an invisibly small amount, some radioactive uranium. And as I bring this rock up to the Geiger counter, the proof of the existence of that radioactivity in the rock is in the fact that an absolute cascade of counts comes out of the counter, almost drowning my voice. This radioactivity itself is not the main point. It is not the means used to date the rocks directly. That's done in the following way, that whenever a radioactive uranium atom decays, emitting one of the particles that we just heard being audibly detected by the counter, it is transformed into a new nucleus and eventually winds up as lead. If the rock is very old, most of the uranium in it has been converted to lead, And when you measure the ratio of uranium to lead by delicate chemical analyses, you find very little uranium and a lot of lead. If the rock is young, very little of the uranium has been converted, and when you measure this ratio, you find mostly uranium and very little lead. So the ratio of uranium to the lead it produces by decay measures the age of the rock. We hope when we make that measurement, our experimenters, that they will find some samples whose ages turn out to be 3.5 billion years or more, and supply us with information on the missing pages of the Earth's and the Moon's history. And that will be the greatest scientific prize that we can possibly capture from the lunar exploration. So the paradox of the Moon is that precisely because it is a poor piece of real estate and probably lifeless, with little or no water, for that very reason it is likely to have preserved the record of its past better than the Earth. And in those samples, we hope or expect that we will find clues to the origin of the Earth, the origin of the solar system, perhaps even the conditions under which life began on the Earth, and organic molecules that give us a hint of the way in which life evolved out of non-living chemicals on this Earth, if that's the way, in fact, in which it happened here. The surface of the Moon can be the Rosetta Stone of the Earth and the solar system and reveal the answer to ancient mysteries.
Now, here in New York is ABC News commentator Frank Reynolds.
And good afternoon from ABC Space Headquarters in New York. With me is our science editor, Jules Bergman, and we are on the air today to bring you a complete report on some very, very important maneuvers to be performed by Apollo 11. Basically, the spacecraft is now about 1,000 miles from the Moon and is about to move into position to begin the process that will eventually lead to the landing on the Moon tomorrow afternoon. In less than 15 minutes or so from now, Apollo 11 moves behind the Moon to the dark side, and we will then lose voice contact with the astronauts. And after about 6 minutes or so, then we will have this first big burn of their main engine aboard the spacecraft that will put them into orbit around the Moon. Jules, this is where it becomes very, very interesting, right?
Right, Frank. About 19 minutes from now, Armstrong, Aldrin, and Collins will fire up their big SPS, or Service Propulsion System engine, a 20,500-pound rocket engine, to slow Apollo 11 so that it's captured by the Moon's gravity. It's a walloping big rocket engine burn, consuming more than 7 tons of fuel and propellant. And it slows the spacecraft, both the CSM and the lunar module are docked together, from their speed at that time of nearly 6,000 miles an hour to 3,700 miles an hour. It's a tricky time. Armstrong, Aldrin, and Collins are on their own. Behind the Moon, we can't hear them. Mission Control can't hear or see them. There's the Moon turning, and Apollo 11 is swinging up like this in its orbit. It's coming up behind the Moon just about at this time. Now, that orbit will carry them about 70 miles behind the Moon if nothing at all is done, if they don't do the lunar orbit burn. If they do it, and they're turned around in a retrograde position for a braking burn, if they do it, they descend closer to the Moon like this and are captured by the Moon's gravity, and then swing around the Moon any number of times like that. In point of fact, 13 times until they get set for the descent maneuvers and the landing tomorrow, as they come around the Moon at that time.
Yes, later on this afternoon, then they'll make another
another
orbit burn, won't they, to come down still lower?
Right. Now let's look at what's going to happen if the LOI burn shouldn't work. They would come up behind the Moon just like this, as they are, so it'll break up there, and swing back to Earth just like that, and land in about 45 hours from this afternoon. There's no reason to think that's going to happen. We're coming up very close now on the scheduled lunar orbit burn time, and this is the way it would look through our simulation inside the Apollo 11 cockpit at this time. Armstrong, Aldrin, and Collins going through the enabling maneuvers. Here's Apollo control.
49 minutes. Apollo 11 should have started this long burn. Duration 6 minutes 2 seconds. Delta V 2,917 feet per second. Given that burn, we expect an orbit of 61 by 169.2 nautical miles. Madrid, AOS. Madrid, AOS.
That's it. The Madrid tracking station has acquired signal. And we're hearing Armstrong very faintly in the background, too faintly to understand. Capcom McCandless calling Apollo 11, saying, Apollo 11, do you read Houston?
We are reading you weekly. Go ahead, over.
That's Bruce McCandless calling. It. That was Neil Armstrong reading back his remaining fuel and burn times to Houston. Very scratchy radio communication. The antennas still aren't set, but Armstrong and his crew are obviously in good shape. The LOI burn went perfectly. As we were saying a short while ago, while we were waiting really to acquire the signal from Apollo 11, Russia's Luna 15 has moved into a slightly higher orbit around the moon. They have, of course, promised to notify Frank Borman that Luna 15 would not in any way, well, they promised to notify him in the event of any substantial change in the flight plan of Luna 15. They have still, of course, not volunteered any information about the ultimate mission of Luna 15, and we don't know yet whether they really do plan to go on down and scoop up some moon rocks and get back to Earth with them before the men of Apollo 11 can do the same. But the Russian flight is, of course, unmanned. We might just go back into history here a bit and recall that day of April 12th, 1961, and our reaction to the Soviet triumph of putting the first man in space. We've looked back to that day quite often since then. Our space triumphs have wiped out, I think, any vestige of humiliation the United States might have felt at that time, but not the memory of it. Here is an excerpt from a program that ABC News did at that time in 1961 with a youthful science editor named Jules Bergman. Look for the Russian animation explaining how they planned to get to the moon. It seemed quite practical 8 years ago. And here is how ABC News noted the one-orbit flight of Yuri Gagarin, the first man in space.
Historic day, one of the most unforgettable of our century. The point of departure for man seeking to reach space. And this man, Yuri Gagarin, major in the Soviet Air Force, is the first to cross the frontier into the unknown of space. 27 years old, swarthy, handsome, highly trained, married to a medical student, the father of 2 girls. Occupation, cosmonaut, the world's first. He has now traveled faster, higher, and farther than any man in the history of this planet. And no other man can yet claim the same occupation or distinction. Tonight, all Russia has gone wild with joy. Delirious crowds in the streets of Moscow, Leningrad, and other cities, hailing the triumph of Soviet science over the West. Russia calls it an unparalleled victory of man over the forces of nature, an immense achievement of science and technology, and the triumph of the human mind. And it is indeed all these things. Now the world is asking, what next? What will Russia try to conquer next in this new world of space? This is what the Russians have in mind for us, a film preview of the future from Soviet science. We're looking at a portion of an extensive film animation prepared by the Soviets of a projected trip to the moon, one they claim will be a reality in the next 5 to 10 years. At the beginning of such a flight, a spaceship propels a multi-stage rocket. As the speed increases, the rocket breaks away, and then various other stages of the rocket also fall away. After a time, it is traveling by inertia alone with no further energy required. Powerful radar stations keep the rocket within the grasp of its radio signals. And automatically operated instruments on the ground send radio impulses back to the rocket from the Earth. and they're received by ground stations. This station guides the rocket with the help of machines to count the electronic impulses. The rocket races forward along an orbit that has been calculated months in advance. But at a command from the Earth, it can launch into another orbit. When a rocket has traveled beyond the Earth's gravity, it can head toward its goal, the gravitational field of the moon. Now a refueling rocket sets out from the Earth, and now our rocket is headed into the moon. When it reaches the moon, a laboratory and tank treads will launch out to explore the moon. The Soviet scientists who designed this project describe it as fully possible. And it may be the next step for the Russians. And so the pattern of Soviet triumph in space. Where are we ask tonight. Our Project Mercury will get off the ground in its first short manned shot near the end of this month. A short ride, 115 miles to the edge of space. April 28th is the earliest date. As for an orbital flight, like Russia did today, that won't come until near the end of the year, maybe not even until early next year. And how do our Mercury astronauts feel about the Soviet triumph? Disappointed, they all tell us today. Naturally, we wanted to be first. 10 days ago at Mercury headquarters, Langley Field, Virginia, I asked Lieutenant Colonel John Glenn, who may well be our first astronaut into space, how he would feel if the Russians beat us into space.
John, if the Russians get a man up before we do, how would you feel about that?
Well, that's a good question because we've been asked this many times. There's only one answer to that. It doesn't change our program one bit. This is like saying that because Henry Ford started a new car first, no one else should be in the automobile business today. The General Motors should have dropped out before they started. Well, this is ridiculous, of course, and it's probably a ridiculous example, but the fact that the Russians happen to get a shot off or may not get a shot off a little bit before we do doesn't alter the objectives of our program a bit. Our program is not set up just as a race to space. We're well aware of the international implications of this, but this doesn't alter the step-by-step progression that we want our program to go through to see that man safely starts space exploration. We have our goals, I guess they have theirs, and the fact that they do or do not get a shot off ahead of us will not alter the objects of Project Mercury.
We're not going to change our plans.
No.
And good afternoon once again. We are, in fact, about to see more pictures now from of the lunar surface from Apollo 11. With me here in our space headquarters in New York is our science editor, Jules Bergman. Jules, these should be interesting shots.
Frank, Apollo 11 is now on the near side of the moon, coming up on the Sea of Tranquility, the landing area where Armstrong and Aldrin are scheduled to land tomorrow at an altitude of 102 miles, and we're just getting the TV picture. Let's go to it for Apollo control.
Apollo control, Houston. We acquired TV at 78 hours, 24 minutes, 11 seconds. Currently, our orbital parameters show 104. Altitude, an apolloon of 170.2, a periloon of 61.3 nautical miles, those are.
Well, this is Houston. Would you care to comment on some of these craters as we go by?
Roger, we're approaching the approach path to ignition. This is equivalent to 13 minutes before ignition, and we're at about 80 degrees east, I guess. 83 degrees east. Does that correspond to location you're holding in, present?
Roger, we're showing your present position is about 76 degrees east, looking back towards the east.
You should be looking back at Smythe Zeno.
Roger.
And we've now heard from all three Apollo 11 crew members during this television pass. The individual talking earlier was Neil Armstrong.
Ranger Schubert. And Gilbert U is in the center right now. back at it, we'd be looking straight down at it at that time.
Roger.
Apollo 11 now flying
I'll show you an
backwards.
altitude now of about 110 miles, and of course you'd be considerably lower at the initiation of powered descent.
This is exactly the same territory Eagle, the lunar module, will be flying over tomorrow as it begins its powered descent toward a landing on Lunar Landing Site 2, now about 100 miles to the west of where we are.
Look at register 3 on the Disky theta. Theta is increasing toward my desired of 315, and I'll let the hand controller alone here, and I'll bet you it reverses itself.
They're just now passing out of Smythe Sea, heading along the lunar equator toward the Sea of Tranquility. And we should be seeing the craters Gilbert and Kastner shortly to the south of their flight path.
Roger 11, we're watching the Disky now, and still coming in beautifully on the TV.
The spacecraft faced around backwards, looking back.
Right side of the screen at the present time, there's a triple crater with a small crater between the first and second, and the one at the bottom of the screen is Schubert Y. Zoom in, it does have a central peak in Schubert Y. Actually several of them, and you can observe those. Plus the rim craters at the bottom of your screen.
Roger, we're seeing the central peak quite clearly now.
Our view of this tomorrow will be much closer, of course, and be down a good deal closer to the lunar
Okay,
surface.
we're zooming in now on a crater called Schubert N. Schubert N, very conical inside walls, and the bottom appears to be nearly flat.
Look at data on the Disky. It's stabilized and is holding steady now.
Roger.
Looking out the window, I can see a number of small craters on the bottom of Schubert N.
We're coming up on the foaming sea where I'll be doing some P-22 marking on a crater of my choice, named Crater Camp.
Okay, we'll be watching for camp.
And notice register 3 has reversed itself and is heading back the other way now without any pitch thruster firing.
Roger, Mike. We confirm that you've changed the direction of your pitch rate.
Looking directly down on the moon from 100 miles over it as they move out of Smythe Sea into the foaming sea on their way toward the Sea of Tranquility.
Generally speaking, the tendency seems to be to pull the LEM down toward the center of the moon as in a gravity gradient experiment.
Roger 11, we copy.
It may have something to do with mass times, or it may...
Roger, we've gotten...
It may have something to do with mass times, or it may just be the peculiarity of the Disky display.
Okay, we've observed the behavior of your Disky. I think we've got the data here to work on it. Let us grind around a little while on it, and we'll report back to you probably in a rev or two.
Okay, well, in the meantime, I'm going to pitch down toward 315.
Roger.
That's Mike Collins, who's flying in the left-hand seat, Spacecraft Commander Neil Armstrong's ordinary seat.
Three horizontal craters that you now have in the field of view are immediately underneath the ground track. The right hand and the largest crater that you see is Dubiago P.
It's Armstrong talking.
concur on the identification of that crater?
Arago B. That's the crater Neil Armstrong has identified. A small crater, as lunar craters go, one about 4
We
miles.
saw you coming up on landmark Alpha 1 here shortly.
Roger, Mike 7, his first look at Alpha 1 at the present time.
These landmarks, like Alpha 1.
Yeah, it's a great, bright crater. It's not a large one, but an extremely bright one. It looks like a very recent, and now it gets impact crater with rays streaming out in all directions, which should make space, so the correction of foaming sea easy to see coming up on it. Now, Crater Camp is one of the smaller ones out on the floor of the foaming sea.
We've been some 17 minutes now into this television pass, standing by, continuing to monitor.
They're now about 80 miles east of landing site 2 in the Sea of Tranquility, moving past the crater Kant, which you saw a moment ago.
This view is from about 110 miles up, too.
Right, they've reached their low point, or pericynthian around the moon, and are heading up toward the high point. And
I'll take over the television camera. Look at that.
Okay, we show you
clarity.
over the Sea of Fertility now, and you ought to have Langrenus down south of Trek a few degrees, about 9 degrees south of Trek.
Yeah, the crater that's in the center of the screen now is Webb. We'd be looking straight down on it at about 6 minutes before our descent. It has a relatively flat bottom to the crater, and you can see maybe 2 or 3 craters that are in the bottom of it. On the western wall, the wall that's now nearest to the camera, near the bottom of the screen, we can see a dimpled crater just on the outside. And then coming back towards the bottom of the screen and to the left, you can see a series of depressions. It's the type of connected craters that give us most interest to discover why they're in the particular patterns that they're in. I'll zoom the camera in and try and give you a little closer look at this.
Roger, we're observing the dimpled crater now. The central peak that we can see on the orbiter photos doesn't seem to stand out very well here.
Well, they're not central peaks, they're depressions in the center.
Roger.
And you'll notice on the pitch sensor activity, I put in a dozen minimum impulses and pitch down, and I'm still far from correcting back to 315. We're moving the camera over to the right window now to give you Langrenus. It's several central peaks, and
Roger, we got Langrenus in our screen now.
And Langrenus is an enormous crater about 160 miles south of their flight path, a crater about 85 miles in diameter. And that's Collins and Armstrong zooming in the camera for a close-up view of it.
Okay, 11, this is Houston. We're getting a beautiful picture of Langrenus now with this rather conspicuous central peak.
Moving along into the Sea of
Fertility doesn't look very fertile to me. I don't know who named it. Well, it may have been named by a gentleman whom this crater was named after, Langrenus. Langrenus was a reasonably accurate maps of the moon.
Roger, that's very interesting.
Now, that sounds better for our purposes than the Sea of Crises.
Amen to that. Okay, it looks like you're coming inside now on the camera.
Well, I can't
can't get behind to see the monitor, I'll bring the focus in, but we're going to be looking down past one of the LEM quads, and one of the antennas almost straight down at the ground track that we'll be seeing coming in. Now, I guess this is maybe 2 or 3 minutes before power descent.
That's Lunar Module pilot Buzz Aldrin telling what we'll be seeing outside the window here of some of the LEM's thruster quads, or little reaction control system engines.
All right, that should put the LEM structure about in focus. I'm going to move it out to infinity and then expand the field of view.
That's Buzz Aldrin, and we're looking at one of the LEM reaction control system quads. He's now zooming past it.
Crater Secchi is out my window now, window number 2.
Apollo 11, this is Houston. We show you coming up on the Terminator at 78:53, about 7 minutes from now. And we've also got the LOI-2 and TEI-5 pads ready for you after the TV, whenever you want to terminate over.
Roger.
And we're getting a good view of the track leading into the landing site now.
Apollo 11 sweeping along at about 3,700 miles an hour over the moon.
How far are they from the landing site now?
Okay, it looks like we had Secchi K go by about 10 seconds ago, coming up on Apollo Ridge.
And they're now about 300 miles.
And in the right-hand portion of our screen right now, we can see Messier, Alpha, and Bravo with the light-colored rays streaming off in one direction.
Capcom Bruce McCandless saying what Apollo Control sees from the same TV picture we're all looking at.
I don't know if you can make out, but in the Sea of Fertility, there are a number of craters that are just barely discernible, old craters whose outlines are just barely able to be seen.
Roger, I think we can make them out. The color really enhances our ability to discern features and craters over what we see in real time on our black and white monitor.
Right. At these low sun angles, there's no trace of brown. It's now returned to a very gray appearance, and like the Atria says, it has a look of plaster of Paris to it at this sun angle, which is completely lacking at higher sun angles.
Roger.
We're now some 25 minutes into our television pass.
And shortly, just along here,
This is very close to ignition point for power descent. Just passing Mount Maryland. That's a triangular-shaped mountain that you'll see in the center of the screen at the present time, with the crater Secchi Theta on top of the far northern edge of the mountain.
I think we're getting a good view of Mount Maryland and of Secchi Theta.
that was Neil Armstrong. They're about 260 miles east of the landing site, just about the point, as Armstrong was saying, where they'll ignite the LEM's descent engine tomorrow to begin their landing.
What we call Boot Hill occurs 20 seconds into the descent.
And it's easy to see what's on Armstrong's mind.
Watching this pass with a great deal of interest in Mission Control Center is Pete Conrad, the commander for the Apollo 12 mission.
Right edge of the screen is Censorinus T. Now passing the 1 minute point in power descent.
Roger, and for your information, your current altitude is 148 nautical miles above the surface.
The clustered Censorinus craters.
I'm unable to determine altitude at all looking out the window. I couldn't tell whether we're down at 60 or up at 170.
I bet you could tell if you were down at 50,000 feet.
I wouldn't be surprised.
The clustered Censorinus craters will be hearing more of tomorrow right along their flight path as they do the power descent burn.
Some steep ridges here, the edges of old craters that were photographed by Apollo 10, and the crew of Apollo 10 was very impressed with the steepness of these ridges when they came over them at about 50,000 feet.
Roger, we can observe they're also steep even from this altitude. You've got quite a shadow being cast by the sun at these low angles.
The entire surface is getting considerably darker than the surface that we looked at previously when the sun was quite high above us. The crater in the right crater in the center of the screen, the smaller one, is Censorinus.
Roger, and we show you a little over 1 minute from the terminator at the present time.
Censorinus, a crater about 18 miles in diameter. And what Armstrong is doing is flying right down the glide slope.
The picture you're receiving, I think we ought to open up the f-stop some as we approach the terminator.
Yeah, the brightness is still doing quite well. You can go ahead and open it up a stop or two. The automatic light level compensation seems to be working beautifully.
It's going to get dark at about the same time they pass over landing site 2 as they hit the terminator.
That's a good picture of Boot Hill.
One of the landmarks into the
Roger, 3 minutes and 15 seconds into the descent.
Roger, we're seeing Boot Hill now.
The next crater coming into the bottom, that's Duke Island right there, and to the left, the crater, the largest of the crater near the center of the picture right now is Maskelyne W. This is a position check during descent at about 3 minutes and 39 seconds, and it's our downrange position check and cross-range position check prior to yawing over face up to acquire the landing radar. Past this point, we would be unable to see the surface below us until getting very near the landing area.
And what Neil Armstrong is saying is that at this point,
you get a real good look at that tomorrow afternoon.
we won't see it this way tomorrow afternoon, of course, because the little TV camera inside the command module won't be with them.
Continuous reel is the one that was referred to in Apollo 10 as Sidewinder. Good name, too. Sidewinder Diamondback. Looks like a couple of snakes down there in the lake bed.
They would now be at about 37,000 feet over the moon if they were in the landing procedure.
And we're approaching the Terminator now. You see the contrast increase, and only the sunlit side of the bridges remain illuminated, while the dark sides in the shadow will become completely black.
11, this is Houston. The picture is getting a little grainy now. You might go ahead and open up the f-stop.
Landing point is just barely into darkness. That one crater, the upper part of which you see, lower part completely in darkness. A small, well-defined crater is Mulkey, which is about a beam of the landing site.
Roger, we can just see it looks like a little less than half of its rim right now.
And it would appear that the orbit of Apollo 11 is perfect.
Just barely some features on the surface, maybe from Earthshine.
The crater Mulkey there, about 30 miles south of their track.
Are you wide open on the f-stop at this time?
Where we are. Yeah, and it looks like we're just about to get the sun coming into the lens, so we'll have to move the camera away.
Roger.
We can't see any Earthshine or any surface features at all in Earthshine now due to the fact that the limb is very bright and is causing our pupils to contract.
Neil Armstrong took us through a dress rehearsal, or a typical instrument landing glide slope procedure showing how he'll do the PDI, the Power Descent Initiate Burn, tomorrow to bring Eagle, their lunar module, down to the landing site, lunar landing site 2 there. And even more important was that he was right on the money, right on the right track, for not 4 or 5 miles south, as Apollo 10 had been over that same site. Apparently, the LOI burn, the trajectory and navigation guidance work, has been absolutely flawless. Armstrong appears to be all set up. Well, and as one of the men just said, looks like the LEM is ready to go down, wants to go down.
Well, it's in a way a million light years between the flight of the Wright brothers at Kitty Hawk, but it's not so very long at that when you stop to think of the actual calendar time. But of course, there have been tremendous strides. Nobody could have dreamed, no realist, I guess, could have dreamed at the time of the Wright brothers' flight that less than 70 years later, people would actually be on the surface of the moon. We have a film package for you. ABC's Don North has put it together to just trace the history of flight. Here's Don North.
Incredible as it may seem, there is only 66 years between this, the first successful aircraft to fly, and the flight of the Apollo 11 spacecraft. 66 years between the flight of Wilbur Wright and Neil Armstrong. It was in this aircraft, a frail combination of wire, wood, and cloth, on December 17th, 1903, that Wilbur Wright launched on the sands at Kitty Hawk, North Carolina, and flew for 12 seconds. He covered a distance of 120 feet. A modest beginning, with few Americans realizing the significance of this achievement. The Wright brothers alone seemed to realize the significance of what they had done. Later, Orville Wright said that it was the first time in the history of the world in which a machine carrying man had raised itself by its own power, raised itself into free flight, and sailed forward on a level course without reduction of speed, and finally landed without being wrecked. A single still photographer was there to record the event. He made this photo. There were no newsmen present. Later, only one newspaper, the Norfolk, Virginia Pilot, printed the story, but they got most of the facts wrong. This film shows an early glider flight about 1902. It was through their experiments with kites and gliders that the Wright brothers developed their successful aircraft. Seen directing operations here, Wilbur Wright on the left. After 1903, the Wright brothers flew their planes in Europe for the governments of France, Germany, and Italy, and achieved worldwide attention. This is the younger Orville Wright. In 1909, they demonstrated this aircraft for the U.S. Army at Fort Myer, Virginia. With Lieutenant Frank Lahm as the passenger, Orville Wright, shown here, satisfied the Army's requirements, and Secretary of War Howard Taft awarded them a prize of $30,000. It was in Italy, before King Emmanuel, that some of the finest film of the Wright brothers' early flights was made. The European powers were very interested in developing the airplane for military purposes, and later Orville Wright was to regret the use of the aircraft he developed in war. He said, "I feel about it as much as I do about fire. I regret its danger, but I'm glad the human race discovered it. This is a catapult launch similar to the idea of a launch from a modern aircraft carrier. There was a brave cameraman here. Notice they never flew very high, about 30 to 50 feet in those days. They weren't too sure of themselves. It was during this demonstration that the first film was made in the air. An intrepid cameraman climbed aboard beside Orville Wright, and they took off down the launch pad to take the first film shot from an airplane.
All right, they've just received the go signal from Mission Control to undock. That will take place around on the far side of the moon. So, Jules, Eagle and Columbia will now come into their own, won't they, on their own?
They're on their own, and they are pretty well committed at this point, and no one's particularly concerned about it. Eagle has checked out amazingly well, far better than it, or most lunar modules and most command modules have done on the ground, and certainly better than any of the astronauts have been able to do in the simulators. It seems to be the story which Stafford and Frank Borman and many other astronaut space commanders have told us, that when you get up there in the real vehicle, it's much easier than in all the practice sessions. It's much easier than in the hundreds of hours in altitude chambers and in test rigs on the ground. The real thing is always easier to fly. And this is the way it will be. This is the way it is now, we should say, just before undocking, which takes place on the far side of the moon, with the command module, Columbia, on the left-hand side of our frame, of course, docked to Eagle, the lunar module, both of them passing in an orbit some 60 miles over the moon. Actually, the orbit varies between 55.9 and 63 nautical miles over the moon's surface. Mike Collins alone now in the command module. Let's go to Houston for a little air-to-ground in these final moments before loss of signal. We just heard Collins talking to Capcom Charlie Duke. Let's see if we can pick them up again. There's the scene in Apollo Control in Houston. Some tenseness at the consoles, a quiet scene, a busy scene, as they watch and wait, as Flight Director Gene Kranz, an expert at this kind of thing, the flight director in charge of the descent maneuver and the lunar touchdown, has his team drilled.
Go ahead, Columbia, over. Roger, there'll be no television in the undocking. I have all available windows either full of heads or cameras, and I'm busy with other things. We concur, over. Eagle, Houston, we'd like you to select aft Omni now. It'll be good for both LOS and AOS, over. Roger, going to aft Omni.
And that was Mike Collins confirming that the live television he'd hoped to do of the undocking now cannot be done. They're switching antenna positions, which is why the signal has suddenly gotten scratchy there. As Eagle and Columbia go over the hill, as the astronauts call it, around the western side of the moon.
Apollo 11 is on the far side of the moon, and we are about 25 minutes away now from the point at which they will undock, actually separate the two spacecraft, Eagle and Columbia. And Jules Bergman is down in our mock-up of Eagle with Dick Sprague. Jules?
Frank, we're in our own Eagle, if you will, our lunar module mock-up here at ABC Space Headquarters with Grumman consulting pilot Dick Sprague, who's right now in what everybody's going to hear is the CDR station, the Spacecraft Commander Station, where Neil Armstrong will be flying Eagle down to the landing. Uptight, if you will, to that triangular window, Dick. Is that right?
Right. This will be Neil's position as he's approaching the surface.
Right. Now, what, Dick, these landing scribes or the LPD, the landing point designator, looks like an old-fashioned reticle, a crosshair, and a telescopic sight on a rifle. What does Neil do with that?
Well, when he stands in the correct position, or the design eye position, aligns these scribes on the inner and outer glasses, he is then looking out at a point on the lunar surface when the computer tells him to.
Right.
And it tells him how many degrees down on that scribe line to look. He will then be looking at the point that the computer has decided to land him at.
For example, if it says 33 degrees, as it nominally does in the flight plan at low gate, that's where 500 feet above the moon's surface, that's where Neil wants it to be, and Buzz, I'm standing in Buzz Aldrin's position here, Buzz wants it to be, for the actual lunar touchdown. We're going to take you through that touchdown now via animated film, picking up with the undocking that's due to take place about 25 minutes from now on the 13th revolution of Eagle and Columbia, their command module, as they pass behind the moon, the far side of the moon. As the animation shows, the two vehicles undock and pull away from one another, and Neil and Buzz are there, and Eagle, their command module, getting ready to start down. There they are, tight at the windows, as Dick Sprague showed us. The descent engine fires, that 10,500-pound DIPS engine, as you'll hear it called, in the DOI, or Descent Orbit Insertion Maneuver, which will lower their altitude from 60 miles around the moon, which is what is it now, down to the 50,000 feet where Tom Stafford and Gene Cernan in Snoopy, their lunar module on Apollo 10, got to. Then after successfully getting down to 50,000 feet, and what really is a continuous maneuver, they do the PDI, or Power Descent Initiate burn, which takes them from 50,000 feet down to the moon's surface. PDI begins 260 miles west of the landing site in the Sea of Tranquility, slowing them down all the way until they finally do the final descent vertically like a helicopter, coming down very, very slowly to what should be a smooth landing. The actual landing area, a 3.2 by 1.6 mile ellipse in the Sea of Tranquility, about 1.5 miles by about 4 miles in size. All the maps so far indicate that ellipse is smooth, that Armstrong and Aldrin should have no trouble. That's the way it'll look as they touch down on the moon's surface.
Not long ago, I talked with Neil Armstrong about, basically the dream that will climax with Apollo 11. You're supposed to be, and you are, a pilot, not a philosopher, but you are going to be the first man to land on the moon. You must have thought well beyond the technical, purely scientific aspects of this mission. So I want to ask you really kind of an impossible question, but you're the man to give the answers. What do you think this mission will tell us about man?
If we are successfully able to execute a touchdown and return, it's going to give us an unmeasurable amount of confidence. I think that's probably the greatest result of the flight. It's going to assure those people who have been spending long hours late at night for many years in the computer labs across the street and in the simulations over in the other building and in the program offices that the almost staggering technical job that they tackled is in fact possible for man to conquer. And given that confidence, we will then be in a much better position to accurately judge what we should tackle in the future. It won't be marred by a lack of understanding of what can and can't be done. It can be judged on its values.
Do you think it might help us to maybe solve some of our less exotic problems here at home, on Earth?
Well, I certainly hope that that we would take the more successful approaches that have been used in this kind of a program and find ways to apply those approaches to other problems. I don't necessarily agree that just because these people have in this approach have been successful that we should take their resources away from them and give them to some other people who have been less successful in their endeavors.
I get the impression you think we might be able to do both.
Well, I certainly think we can. We're a great country. We have a lot of abilities, and when we direct our efforts toward an understood goal, we usually solve the problems.
You know, I think I was wrong in putting that question to him in the way I phrased it. He is a philosopher, too, as well as a pilot. He's a young man who means what he says and says what he means. We're back in mission control now to see if we can't get some more communication.
Houston, Columbia, my disk is reading 4.9. NX 5.0 make it, and EMS 105.4, over.
Roger, copy, Columbia, looks good to us, over.
Okay.
should have confirmation of the separation burn momentarily. Collins said a few seconds ago to Armstrong and Aldrin, you've got a fine-looking flying machine there, meaning he'd given him his go.
Houston, we'd like you to terminate average G, over.
Roger, info.
B, he said.
We're waiting now to get confirmation of this separation burn.
Right, Frank. A quiet time there. The burn should just have happened.
They'll still be in visual sight of one another, though, won't they?
Right. They'll stay in visual sight for quite some time. As they slowly drift apart, Collins does a small reaction control system thruster burn with Columbia's thrusters. Slowly pulls away and watches Eagle. Indeed, he can see Eagle all the way down, almost to landing. He'll see it.
This is Apollo Control. That separation maneuver was performed as scheduled, giving the command module a delta V of about 2.5 feet per second, which should give a separation to the two vehicles of about 1,100 feet at the beginning of the descent orbit insertion maneuver.
This is Frank Reynolds with Jules Bergman at ABC Space Headquarters in New York. We should tell you what Armstrong radioed to Mike Collins as he moved away in Columbia after the separation burn. He said, "You're going right down US 1, Mike." And Collins moved away, and now they are flying in tandem, so to speak, until the time comes for the DOI, or the descent orbit initiation, when they will start down in Eagle toward the surface of the moon, and Mike Collins in Columbia continues, of course, to orbit around as sort of a watchful mother hen to watch every move they make. In the event they encounter any difficulty on the way down, he does have the capability to go to a certain point, and try to rescue them. And, of course, he'll be very happy to see them come back when they crawl through that tunnel again late tomorrow afternoon.
He can get pretty low, Frank.
Well, how far down can he go? He said the other day about 10 miles, didn't he?
It varies a little bit, but Collins has apparently rehearsed the fine art of rescue in abort modes to the point where he can actually get the Columbia command module down to 20 or 25,000 feet above the moon's surface if he has to. In the unlikely event that all the lunar module's engines failed and Armstrong and Aldrin couldn't abort by themselves to get back up to the Columbia. So Collins can get down within 5 miles of the moon's surface.
Within 5 miles.
That's pretty low.
It sure is. He's at about 69 or 70 now.
I remember, I think you were there when I talked to Mike that day, and Mike's principal concern was, no one is sure how high some of those craters, how low some of the craters are and how high many of the mountains are on the moon's surface, and you're coming along, it's like avoiding television towers and buildings in an airplane coming in a rainstorm. You've got to be darn sure what's going on. So that's one big thing he's worried about.
Yes, you're like trying to land at, say, one of New York's airports without knowing very much about how the buildings were around New York. Well, we thought we'd have some heavy thinkers here now for a change, and take a small break while Jules and I get a moment of rest. And we're going to have some thoughts by three very important people about why we should be going to the moon. Here's Bill Moyers, the editor of Newsday, Marshall McLuhan, the philosopher of communications technology, and Ian McHarg, a regional planner, amateur ecologist, author of Design with Nature. ABC's Howard K. Smith asked Mr. McHarg about the motives that send Earthmen to the moon.
I would give all honor to the astronauts and NASA for this, phenomenal adventure, but it seems to me there are two motives here, one of which is good and the other, I think, quite bad. One, the good motive is the increase in man's knowledge. The bad motive, I think, is the motivation of conquest, and I think our attitude to nature has been, throughout the whole Western tradition, one of conquest. We talk about conquering Mount Everest and conquering the moon and conquering space. And we have, traditionally this whole culture, thick, low-browed, dull-witted, territorial, laying bludgeoning strokes across, the world-life body, destroying and singing paeans of self-praise as we go. And I think there is an aspect of this, you see, in the conquest of space, that it is really base. It's the same witless...
It's metaphoric, though. When you say the conquest of space, you mean it's a metaphor.
Oh, I think it's not a metaphor. I really believe the Western tradition does believe that man has a moral duty to conquer nature. I mean, he is exclusively divine, or so the Genesis tells him, given dominion over life and non-life, and joined to subdue the earth. And by God, the whole Western tradition, Judaic and Christian, has tried to give the best evidence of this dominion and subjugation that it possibly can. And the conquest of space is just one of the spin-offs of this arrogant, anthropocentric, witless, clottish man who insists in subjugating the earth and all creatures.
I don't look at it that way.
I was going to ask you.
I think man is essentially an explorer. He's always reached out into the unknown, and Mr. McLuhan said earlier that if something can be done, it will be done, and man is going to determine that he can do this. I think it is not a greedy, avaricious reach for something that he would like to control as much as it is for something about which he would like to know more. And I think as long as there is something unknown, man will be trying to reach for it. What I've learned from all of this is that man also, as a political animal, has the capacity to organize himself and his peers in such a way to attain a goal that a decade ago seemed to be impossible and seemed to be forbidding. And what I hope that we can do from this is to see the difference that exists between what we've done in space and what we yet have to do on Earth, and organize ourselves to achieve the goals which will affect the lives of billions of people on the Earth, as well as the lives that will be affected of a few men who will make it into space.
Bill, you were in a high place in government at a time when this program was launched. Do you think that it's been a wasted effort, that it has been a perversion of resources and skills?
No, I don't, for this reason. We were not doing very much in the social and domestic field in the late 1950s when we were not searching for the moon or reaching into space. We have done more on Earth since we have been doing more in space than we ever did in the decade before. That's a syllogism, perhaps, which proves nothing except the fact that this nation is so wealthy and so rich that it really has the capacity to do what it will organize itself to do and what it establishes as its priorities.
But, Mr. Moyer, have you considered that the Russians, who have never had a 19th century, who have many less resources than we, have also accomplished more or less the same goals in space?
But at a greater price. You see, their GNP is such that they could not carry on a consumer revolution at the same time we have been doing that.
All right.
And so they had to give up something. I don't think we have to give up something. I think we do, because it is so much easier to reach a goal that has few political obstacles in front of it than it is to try to do something about some of these problems which have political
It's just a kind of luxury for us to play with these things, whereas it's life and death for the Russians.
No, it's not life and death with them. They made it a matter of life and death.
On the other hand,
the allocation of their very meager resources.
On the other hand, with Sputnik, they created a very witty pun, which was carried out visually. Little fellow traveler. They put this little fellow traveler as an environment around the planet, a planet that was terrified of fellow travelers, and they put a little one out there to reassure us that it was friendly.
They didn't create the pun, Mr. McLuhan, you did.
Well, the word Sputnik means little fellow traveler in Russian. And it was done at the time when fellow travelers were rather a menace in our world.
They did it for a very esoteric group of men of whom you are the paramount chief.
No, I'm very flattered, but I heard that from a great many other people. I didn't probe into the etymologies of the word. But it is, I think it's worth considering, since they do have a sense of humor, what the Russians had in mind in the complementarity of this current effort.
Yeah. I think I think at least in the beginning, Mr. Smith, they had a military purpose behind their space effort. And I think this is one of the reasons that our leaders at that particular time, particularly in 1960 and 61, were motivated out of a sense of reaction, even to some extent fear, which has been translated into the prestigious reach for to be first in space. But I think they really had serious military motives behind their
are there, when you say serious military motives, I shouldn't think military motives half as serious as many others, including educational. But when you attach the word serious to military, I don't.
It can be attached to almost any word. Well, there are many military efforts that we're making that are not serious in the sense of their relevance.
You don't think of you don't think of Apollo 11 as having any relation to our own military interests?
By all means, the present head of the Apollo program, who is a general, indicated today that he will be leaving the Apollo program a few days after the flight in order to go back to the Pentagon to apply the techniques he's learned in the Apollo program to our defense effort. So I think, to go back to one of your first questions for 1 second, you said, what is the value of this? Well, there are many esoteric values that are still to be realized. There are many long-range projected values that the millennia will realize, but the immediate value is military. Let's face that. The practical, significant application of our space effort, if it has any pragmatic value whatsoever, is basically military.
Let's ask ourselves in long-term projects about the meteorological possibilities of the conquest of moon space.
You better ask him.
Can we consider the possibility of space platforms that might serve the control of climatic conditions eventually on Earth?
I haven't a finished idea. I'm the wrong man to ask about this. I do know that satellites orbiting the Earth, of course, can have an enormous utility. They now have elaborate sensors. The Interior Department is going to send up another satellite. Is it not Eris? And this beautiful creature will be able to monitor the Earth continuously, and we'll be able to observe things as delicate as the amount of carbon dioxide or the productive fertility or health of crops, sedimentation in rivers and so on. The whole dynamism of natural processes may be continuously monitored. This material could be digitized into computers immediately, and that material can be used by people like me to make regional planning decisions, and this is enormous social utility.
A historical moment, a historical point here. Back in the early days of the space effort, and even into the acceleration of the Apollo program in the early days of 64 and 65, the men who brought to the president, to the White House, the projections, the facts, the research, the figures, were very realistic about the immediate practical effects of this whole program. As far as interplanetary travel is concerned, it will remain for generations to come a very esoteric feasibility, for the very simple reason that it'll be a long time and take many billions of dollars before we can develop the kinds of programs that will make interplanetary travel, vehicles that will make interplanetary travel available to more than 3 or 4 men at a time. To go to the Mars, for example, is a 2.5-year round trip.
Mr. Moyers, you are working on the assumption that the present forms of fuel and hardware are indispensable for such travel.
One of the reasons they want the specimens from the moon is to see to what extent minerals exist in the moon, in the quantities of moon material that can be used for space fuel. They may not exist, but that's one of the purposes.
It's not at all likely that we're going to continue our present forms of fuel for earthly transport, let alone interplanetary transport. We can tell by saturation and pollution that we're reaching a terminus in many areas of use of materials. And at any time, like the automobile, we know the automobile is, we don't know why, we know it's finished because technologically it has become such an incredible nuisance. But by the time any form of human activity becomes surfeiting and sheer pollution, then you know a big change is handy. The hidden change created by moonshot is the creation of a totally new environment for human knowledge.
Well, thank you very much indeed.
Let's go to Mission Control in Houston.
Columbia, Houston, over.
Houston, Columbia, reading you loud and clear. How many?
Roger, bye-bye, Mike. How did it go, over?
Listen, Dave, everything's going just swimmingly. Beautiful.
Great. We're standing by for Eagle.
Mike Collins saying the descent orbit burn. I'm fine.
We got you out. And Columbia, Houston, we expect to lose your high gain sometime during the power descent, over.
Columbia, roger. You don't much care, do you?
No, sir.
Okay.
acquisition of signal from the LEM.
And we're having some antenna problems with Eagle. Power control not yet getting good quality. At this point, Eagle, as you heard Doug Ward in Mission Control saying, is descending through 12 and a half miles over the moon, nearly at the lowest point.
Houston, we have you now. Do you read over?
Loud and clear.
Roger, we see your Verb 47.
That's Buzz Aldrin talking to Charlie Duke, the Capcom.
Yeah, I don't know what the problem was there. It just started oscillating around in yaw. According to the needle, we're picking up a little oscillation right now, as a matter of fact.
Roger, we'll work on it.
Aldrin is referring to the LEM steerable antenna. That comment about the oscillations.
Good, clear communications now.
Check was right on time.
Roger.
Armstrong confirming he's finished his checklist.
Did you copy the the sun check, Charlie?
That's affirmative. We did, Buzz. Out.
And Eagle now beginning to swing around the eastern side of the moon and back in touch with the Earth. Coming up on landing site 1, above which they will do the power descent burn to land themselves 260 miles further east on landing site 2.
Eagle, Houston, the AGS initialization looks good to us, over.
Roger.
Confirming the abort guidance system, and the test worked fine. Collins in the command module, 50 miles overhead and slightly ahead of the Eagle.
Gene Kranz getting a go, no-go for descent.
Eagle, Houston, if you read your go for power descent, over. Columbia, Houston, we've lost him on the high gain again. Would you please, we recommend he yaw right 10 degrees and reacquire.
Eagle, this is Columbia. Your go for PDI, and they recommend you yaw right 10 degrees and try the high gain again.
So, hitting 10%.
That was Buzz Aldrin telling us he was up to 10% throttle on the PDI burn before the radio communications cut out again. The 10% throttle meaning it's going okay as he descends through 46,000 feet, the last count. And then they had trouble with that LEM steerable antenna again. But they're headed downward.
Columbia, Houston, we've lost him. Tell him to go aft on me, over.
Mike.
Thank you, Neil.
I'll leave it in flu. Relay to us. See if they got me now. I got good signal strength in flu.
Yeah, you should have me now, Houston.
Eagle, we got you now. It's looking good, over.
Hey, Eagle, that looks good.
Eagle, Houston, everything's looking good here, over.
Roger, copy.
Eagle, Houston, after yaw around angles, S-band pitch, -9er, yaw, +18.
Copy.
Ike's and things agree very closely. Roger. Rate on. Altitude's a little high.
Two minutes, 20 seconds, everything looking good. We show altitude about 47,000 feet.
Right on the money.
Yeah. Bill?
Houston, I'm getting a little fluctuation in the AC voltage now. Roger. Just the meter maybe, huh? Stand by. It's looking good to us. You're still looking good. It's coming up 3 minutes. That's real good. Hold it. Start on. Our position check downrange to us to be a little long. Roger, copy. Action's going about 2 feet per second, greater rate.
That was Armstrong saying they're a little long downrange on position. We'll have to correct slightly. They should be through 45,000 feet now.
I think it's going to stop.
There's Aldrin again.
Eagle, Houston, you're a go to continue at all at 4 minutes. Roger, you're a go to continue power descent. You're a go to continue power descent. Roger.
Altitude 40,000.
And Eagle, Houston, we got data dropouts. You're still looking good.
They should be coming up on landing radar acquisition now. The ground beneath them telling them exactly how high they are.
Good lock on?
That's it.
They've got it.
Radar lock.
Altitude lights out. LH is minus 2,900. Roger, we copy. At the Earth, right out our front window. Houston, you're looking at our Delta H. That's affirmative. Program alarm. Looking good to us, over. 1202. 1202.
Good radar data. Altitude now 33,500 feet.
Give us a reading on the 1202 program alarm. Roger, we got you. We're going at alarm. Roger, 330. 6 plus 25, throttle down. 6 plus 25, throttle down. Roger, copy. 6 plus 25.
We're still go. Altitude 27,000 feet.
Same alarm, and it appears to come up when we have a 1668 up. Roger, copy.
Eagle should be slowed to 1,200 miles an hour now.
Eagle, Houston, we'll monitor your Delta H. Beautifully. Delta H looks good now. Roger, Delta H is looking good to us. Wow. Throttle on time. Roger, copy, throttle down. Throttle down. Better in the simulator. Roger.
About 60 miles from their landing site.
Heights and things look real close.
Altitude now 21,000 feet, still looking very good.
And they should be down to 800 miles an hour forward speed, about 102 miles an hour vertical speed as they
Velocity
drop.
down now to 1,200 feet per second.
You're looking great to us, Eagle.
Less than 5
Okay, I'm still on flu, so we may tend to lose as we gradually pitch over. Let me try auto again now, see what happens.
Roger.
Okay, looks like it's holding.
Roger, we got good data.
They're following their flight plan almost unbelievably closely to this point.
7 minutes, 30 seconds into the burn. Altitude 16,300 feet.
Eagle, Houston, is descent to fuel to monitor, over.
402. Altitude 13,005.
Final radar check coming
Velocity
up.
9,100 feet per second.
Made it, switch over time, please, Houston.
Roger, stand by. You're looking great at 8 minutes.
Correction on that velocity, now reading 760 feet per second.
It's the P-64.
Good. Roger.
Fido says we're go, altitude 9,200 feet.
830, you're looking great.
Descent rate 129 feet per second.
We copy.
Or about 80 miles an hour. And they're down to 300 miles an hour forward speed, coming up on High Gate, the next critical point.
Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase, everything looking good. Altitude 5,200 feet.
Manual attitude control is good.
Roger, copy.
Altitude 4,200.
Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet.
Copy.
Alarm. 1201.
1201. Roger, 1201 alarm. We're go. Same type. We're go.
2,000 feet. 2,000 feet. Into the ag. 47 degrees.
Roger.
37 degrees.
Eagle looking great. You're go.
Altitude 1,600. 1,400 feet, still looking very good.
Roger, 1202. We copy it.
35 degrees. 35 degrees. 750. Coming down to 23. 700 feet, 21 down. 33 degrees. 100 feet down at 19. 540 feet down at 30. Down at 15. And 400 feet down at 9. Gate forward. 1050 feet down at 4. 30.5 down. They're pegged on horizontal velocity. 300 feet down, 3.5. 47 forward. Hold up. On 1.5 down. 70. Epic shadow out there. 50 down at 2.5. 19 forward. Altitude, velocity, light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. 9 forward. Good. 120 feet. 100 feet, 3.5 down, 9 forward. 5%. 185. 75 feet, Car's looking good, down a half. 6 forward.
60 seconds.
Lights on. 6.
Lights on.
Down 2.5. Forward. Forward. At 40 feet, down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drifting to the right a little. 20, down a half.
30 seconds.
Forward, just. Good. Okay. Contact light. Okay, engine stop. ACA at a descent. Host control both auto, descent engine command override off. Engine arm off. 413 is in.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Thank you.
You're looking good here.
Okay, we're going to be busy for a minute. After arm on, take care of the descent. I'll get the stuff prepared. Very smooth touchdown. That's good. Looks like we're bending the oxidizer now.
Roger, Eagle, and you are safe for T1. Over. Eagle, you are safe for T1.
Roger.
And we
Sam, stay for T1.
Roger, and we see you venting the ox.
Roger. Radar circuit breaker.
Is that right?
Armstrong and Aldrin have made it. And everyone wondered what Neil Armstrong's first words would be. This is Tranquility Base. Tranquility Base.
Copy, now 60, now 43. Over.
Roger, we have it.
Yes, sir. I read Columbia on the high game.
Roger, we rigged you 5 by Columbia. He has landed Tranquility Base. Eagle is at Tranquility. Over.
Yeah, I heard the whole thing.
Well, good show.
Collins and the Columbia Command Module.
Fantastic.
Good show.
Top reset.
There was never any doubt about what Armstrong was going to do. He had a low fuel light on there, his fuel warning light, and he was very near not being able to do it.
The next major stay, no stay, will be for the T2 event. That is at 21 minutes, 26 seconds after initiation of powered descent.
Columbia went up telemetry command reset to reacquire on the high game.
Copy out.
And there seems to be an absence of drama and emotion in Armstrong and Aldrin's voice. They're busy checking out the spacecraft to be sure they can get off the moon in a hurry if anything goes wrong. And nothing has gone wrong, though. Every sign, Frank, seems to indicate it's okay. And when he was at 40 feet there, it said some dust being kicked up by the engine.
Yes. He must have set that thing.
We have an unofficial time for that touchdown of 102 hours, 45 minutes, 42 seconds, and we will update that.
It was so unerring, it was almost unbelievable.
Eagle, Houston, you loaded R2 wrong. We want 10254.
Roger.
The descent took them just a little bit longer than had been calculated, but outside of that, he followed the descent flight plan second by second, as far as we could tell.
He was able to make the adjustment himself. He was actually flying it down with Buzz calling out all those numbers to him.
Right. Those last numbers we heard were the forward speed and the descent speed of Eagle. Now at Tranquility Base. 2 Americans on another planet. Still ahead, if all these checks go right, of course, about 10 hours from now, unless Neil decides to do it sooner, that 2-hour and 40-minute spacewalk. Another tough bit of action, but not nearly the crunch. Moonwalk. Yes. Not nearly the crunch, as you put it, that landing was. And the next big crunch, I think, is the ascent.
Sure. These men breed a confidence in the rest of us, though, by their own actions.
Houston, that may have seemed like a very long final phase. The auto-targeting was taking us right into a football field-sized crater with a large number of big boulders and rocks for about 1 or 2 crater diameters around it. And it required us going in P-66 and flying manually over the rock field to find a reasonably good area.
Roger, we copy. It was beautiful from here. Tranquility, over.
Armstrong was right. He said he'd have to do it by manual control.
It's a good thing he did, too, because the automatic
was... We'll get to the details of what's around here, but it looks like a collection of just about every variety of shape, angularity, granularity, but every variety of rock you could find. The color is, well, it varies pretty much depending on how you're looking relative to the zero phase point. There doesn't appear to be too much of a general color at all. However, it looks as though some of the rocks and boulders, of which there are quite a few in the near area, looks as though they're going to have some interesting colors to them, over.
Roger, copy. Sounds good to us, Tranquility. We'll let you press on through the simulated countdown, and we'll talk to you later, over.
Roger. Okay, this 16G is just like the airplane.
Roger, Tranquility. Be advised, there are lots of smiling faces in this room and all over the world, over.
Capcom.
There are 2 of them up here.
Roger, it was a beautiful job, you guys.
And don't forget one in the command module.
Roger.
Mike Collins. And Capcom Charlie Duke telling him to get back to that simulated countdown to...
That last remark from Mike Collins at an altitude of 60 miles. The comments on the landing, on the manual takeover, came from Neil Armstrong. Buzz Aldrin followed that with a description of the lunar surface and the rocks and boulders that they're able to see out the window of the LEM.
One last engine remaining to be tried. 96 engines aboard that Saturn V, the command module, the lunar module, and one big one remaining untried, the ascent engine for liftoff tomorrow afternoon to rejoin Columbia, the mothership, and Mike Collins, orbiting the moon 60 miles overhead, Tranquility Base. A new word, a new place in the solar system.
How did the country react? Well, let's find out about the capital anyway, and let's go to Washington now to see just what happened there. ABC's Sam Donaldson. Okay, I'll wait.
Man on the moon. These people are on the Connecticut Avenue sidewalk outside our ABC News Bureau across from the Mayflower Hotel. We have just seen the confirmation that the lunar landing is a successful one, that man is, in fact, on the moon. ABC News has been providing this service all weekend, but nowhere has there been as much excitement as there has been just for the last few minutes as we have gotten confirmation of the moon landing. And let's find out what people think. What's your name?
My name is Hiram Vega.
How has this affected you?
Well, we are from New York City. We are Puerto Rican, and then we was going to...
Yeah, but tell me how you think the moon landing has affected you.
Well, I'm very surprised about this. This is wonderful. It's something unbelievable.
You think it would ever happen?
No, I believe this will be something really... they're going to be very successful.
Thank you very much. Madam, tell me what you feel at this moment.
Well, I think it's one of the greatest achievements in the aeronautical world.
When you were a little girl, did you ever think you'd see men on the moon?
Well, I used to tell people to go to the moon. I don't know. I think, yes, I believe I would.
Have you ever had an experience that has affected you quite this way?
Well, not in this, no, but in some cases, yes.
Thank you very much. What's your name, sir?
I'm Earl Boyd Pierce, a lawyer from Muskogee, Oklahoma.
What do you think about
I've witnessed the landing on the moon. I think it's one of the greatest feats of all time.
Does it amaze you that it's taken place?
It not only amazes me, but I'm certain that it amazes everybody in this country.
Do you think it's worth it?
It's certainly worth it, and it's the greatest accomplishment of the people of this nation. There isn't a question about that.
Thank you very much.
Yes.
What is your name, sir?
Frank Stanley.
What do you think about this moon landing?
Well, it's the beginning of a new frontier, the gateway to Mars.
What do you think about the astronauts, Armstrong and Aldrin?
It's a great achievement.
Do you think it took great courage to do what they've done?
It took teamwork. Teamwork was all.
Are you proud of the fact that we've landed on the moon?
Very proud.
Thank you very much. Tell us your name.
Kathy Walhouse.
And your feeling about seeing two men on the moon.
Exciting. Everybody's always excited when you go to a new place, when you have a new frontier, when you have hope that perhaps as we advance scientifically to the place where we can go to the moon, we don't have to advance scientifically to have test tube babies.
Well, let me ask you a question which may seem irrelevant, but we've heard a great deal about the romance having gone out of the moon now, all of the romantic songs. Do you think it's going to be the same for you?
No. I'd like to go.
Well, in what ways has it changed?
Because of all of the things that have gone on before in space. Perhaps we assume that we can always make it. We don't think anything can go wrong. For example...
Well, I'm actually speaking about earthly romance. Two lovers who look at the moon, you see, and spoon by it, as an old song used to go. Is it going to change for them?
I doubt it. I don't think human beings change that much no matter where they are.
The moon will still be a nice object.
A nice object to watch, and it'll be a nice object to live on, perhaps.
Thank you very much.
We're told now that President Nixon watched the touchdown on the moon on a portable color television set in the executive office building just across the street from the White House. Immediately after the landing, he called Secretary of State Rogers at home. He said it is the greatest moment of our time. The success of this operation will be immensely favorable and will bring the people of the world closer together. That seemed to be what Mrs. Armstrong, the astronaut's mother, was saying shortly after the touchdown. The president went on to say these procedures are the greatest steps in the history of mankind, and as Dr. Payne may have reported just a moment ago, he told Dr. Payne later on the same modern technology that got men to the moon will get them back. Jules?
Frank, we're going to attempt to give our audience an idea topographically on the moon's surface of exactly where Armstrong and Aldrin did land in Eagle at Tranquility Base. We're going to use our telestrator, this amazing electronic device, to show them how what actually happened in the landing process. They were due to land, if the camera can pan just a little bit left on this lunar topographic chart. A little more left now till we pick up the ellipse that was the original target. More left, slightly more left. There we are. Now, we're electronically implanting on the target card, this was these were the actual descent charts used by Armstrong and Aldrin, the original ellipse. Well, we were too low somehow. We'll try again. That was the original ellipse there. And what happened as Apollo 11, as the Eagle swept in her approach card over the lunar equator, Armstrong looked ahead and saw that this area had this football-sized field, a crater field full of boulders, and in effect overshot it. We're a little off on our lines here. Overshot it and came down 4 miles to the west in a new area right about here, just south of the lunar equator, in a perfect landing procedure. And the amazing thing was that he needed every bit of his fuel reserve to do the maneuver with.
Well, Jules...
The telestrator is an amazing electronic device, Frank, that enables us to electronically write on a television set and directly to home audiences.
Yes, well, the thing that I wonder about, though, this football field full of rocks, had that been charted? Did they know in advance? Was that in the actual landing site area?
That was the precise actual landing site area, Frank, that was on the lunar orbiter charts. Now, I'll go over that again for a second. The amazing thing, and I still don't quite understand all of this, is that our pictures were formed from lunar orbiter pictures which were taken rather high over the moon's surface, and apparently missed this area. Lunar orbiter's pictures were supposed to be down to 1 meter or 3-foot resolution in many cases. Remember, I mentioned earlier that orbiter was capable of 1 meter, 3-foot resolution, just about like that. And indeed, the scientists had spotted 6,000 craters, large, small, medium, minute craters in this area. But apparently the football field-sized crater was completely missed. So it was old-fashioned pilot judgment by Neil Armstrong. Neil Armstrong, the flying kid who started at 15, who came in, saw the problem, and landed long, used up half of his remaining fuel reserve, and came darn close to having to abort, but did a beautiful job.
You know, none of the astronauts involved in this historic event, this very dangerous operation, is due to become a millionaire out of it. As a matter of fact, I think Buzz Aldrin said not long ago, when somebody said to him, what are you going to do after the flight? He said, well, I'm not going to become a millionaire. Money doesn't seem terribly important to them in that sense, and perhaps it's a good thing that they have other motivations. Neil Armstrong gets about $30,000 a year. He is a civilian, of course. As a government employee, at his grade, he gets about $30,000. Colonel Aldrin gets about $18,000, I think, and Michael Collins, who was a lieutenant colonel, gets around $17,000 or so with all the flight pay and so forth. There is somebody who is going to make more from their landing than they will make in a year. Well, not quite more than what Neil Armstrong will make in a year. There's a 26-year-old Englishman. We told you about him some time ago. He made a bet 5 years ago that man would land on the moon before 1971. And now he stands to win $24,000. David Threlfall is the man's name. He's a science fiction buff. And he took odds of 1,000 to 1 from one of England's largest bookmakers. He said he was just playing a hunch bet. And I suppose 5 years ago, 1,000 to 1? Well, I don't know, Jules. I think that the bookmakers kind of deserve to suffer their fate. 5 years ago, it didn't seem that it would be 1,000 to 1 shot, did it?
Maybe 100 to 1. 1,000 to 1 seems pretty outlandish to me.
Nobody was giving me any odds of that kind 5 years ago.
You weren't in the right places, Frank.
Well, anyway, we have David Threlfall in London, and I guess he's collected his check, and let's go to London and see the man.
David Threlfall is a young Englishman. In the normal course of things, nobody would ever hear much about him. But 5 years ago, he bet 10 pounds, $24, that somebody from someplace on Earth would touch on the moon by 1971. William Hill, a bookie here in London, took the bet at odds of 1,000 to 1. Tonight, with the touchdown on the moon, David Threlfall collects $24,000. Now, when you placed your bet with William Hill, you didn't say that it will be an American on the moon by 1970.
No, I was anyone, Chinese, Japanese, a man, woman, or child from any nation on Earth. That was the wording of the bet.
You made it that specific, man, woman, or child from any nation on Earth.
I wanted to say woman or child because I wasn't sure of the payload you could carry. I thought you might be tight for weight, so I tried to cover every option and tried to make it as unambiguous as possible.
Well, 5 years ago, it was a bet. Obviously, it was a bet because William Hill was quoting odds of 1,000 to 1. When did you begin to feel that, by heaven, you're going to win this bet?
I think it was in 1966 when they proved that they could do a soft landing, that it wasn't green cheese or a mile of dust. I think that was the only factor. There was some doubt when the 3 Americans lost their lives and there was a delay in the program. But once they got over that, then I was always certain.
The British are not getting much glory out of this landing on the moon, but here in London there is a little pride that apparently an Englishman at least is going to get the most money out of it. This is Bill Butel, ABC News, London.
Oh, here comes Mrs. Armstrong out of her home. Let's go to Texas.
Is it easier now?
Yes. Yes and no.
How did it feel at the moment of touchdown?
Oh, I was terribly excited. It's a marvelous thing that we have successfully managed to land safely on the moon.
What was the reaction of the children, the 2 boys?
We were very excited.
Neil had a slight problem with Gemini 8 with a malfunctioning thruster. Perhaps you can move just a moment. Your light is just behind you, just a little bit to the left or right. Had a problem with a malfunctioning thruster. There were no problems this time. It must have been quite a difference as you were following along.
Yes, it was.
Is Neil carrying anything for you to the moon?
Yes, but that's private.
You're not going to tell us? Animal or vegetable or mineral? Was there any special incantation today, any special prayer, something that you can share with us that you had as those moments near touchdown came?
No, we have said our prayers all along. From the time they had separation, we knew it was go all the way, and I didn't say any extra special prayers at that time. My faith is with me always.
I'm told that Neil was a very poor history student as a boy. Now he's made history. You going to encourage the two boys to become astronauts?
No, I will encourage the boys to do whatever they would like to do.
What do you think they'd like to do?
That's completely up to them.
Miss Armstrong, can you describe what you were doing at the moment of touchdown?
I was sitting on the bed in my room, and I was watching the map minute by minute and following all the craters which they were going over, and doing the best I could to follow them all the way.
Your husband had to do a little bit of flying. Is that suspenseful for you?
No, sir.
And there was a little bit of a problem with communications for a while. Was that a tense moment?
No.
What is that pin that you've got? Maybe you can describe that. It says JA, and it's a model of the lunar module.
Well, that's a model pin, which is a model of the LEM with my initials on it, which I
Jan Armstrong.
very highly.
Where did you get it, Miss Armstrong? Yes. Where did it come from?
It was a gift.
From Neil? From your husband?
Can you tell us what you'll be doing tonight and from now on?
I will be continuing to follow the flight and listening to their descriptions on the moon. Probably reading them in the mission reports again and over and over and over again. I think it's fantastic, and I'm just about as excited as you all are.
Are you following?
Well, I have here a reservation for a flight to the moon as a paying passenger, although I haven't paid anybody anything for this card. It's a card issued by Pan American World Airways to people who apply for seats on the first flight, or the first flight they can get. And you know, more than 17,000 persons already have applied to Pan Am. Pan Am isn't making any promises about this, but the airline does say quite soberly that commercial aviation is never very far behind scientific pioneering. As Jules Verne said 100 years ago, an American sees no real difficulty in anything. And whole families have reserved space on the first flights, despite the estimated round-trip fare of $28,000 per person. ABC News talked to several happy applicants at the Pan Am ticket office in New York.
What do you expect to see on the moon, Andrew?
Craters.
Craters, and what else?
Big holes.
Well, what will be most interesting that you see from the moon?
Craters.
My main desire in life would be to be an astronaut, but I've been a little bit more practical. And I heard about the Pan Am waiting list for the moon, and I decided that would be the next best thing to being an astronaut.
So many people nowadays are concerned with weight watching and how to go on diets. Might be nice just to go to the moon and sense that feel of weightlessness without all the effort.
If I ever go to the moon, I think it'll be very fun. I just hope to go very, very soon, and I hope I'm not really that old.
The moon, I think, would be very sandy and not very pretty to look at, and all these big crater holes and everything else. But I'm just wondering, do you need oxygen to go to the moon? Because I need very little of it. I would be a very good passenger, I think, to go to the moon, because I need very little sleep, need no medication, and I need little oxygen, and I can stay on a liquid diet for weeks. And if we come down and splash down in the ocean, I can float by the hour. So I think it wouldn't be a bad idea to go to the moon, even at my age.
Be advised now that the men are going to walk on the moon tonight, so better not plan to be anywhere very far from a television set at approximately 8 o'clock Central Daylight Time, 9 o'clock in the east. And that is when we now expect that they will open the hatch on the spacecraft and Neil Armstrong will come down and we will have this historic walk on the moon. Well, this is, we are covering here, of course, the event of, some might say, of the century. But other things have been happening in the world today, many other things. And in order to bring you up to date on what has been taking place while the rest of us have been watching the progress of the moonshot, here is ABC's Peter Jennings. Peter?
There was other news today. The Middle East conflict heated up with an air fight between Israeli and Egyptian planes over the Suez Canal. Egypt says it shot down 17 of the Israeli jets, but Israel admits to losing only 2. And in return, reports shooting down 5 of the Egyptian planes. The Israeli report adds that the 2 pilots of their downed planes bailed out and landed safely in home territory. About the only fact on which both sides agree is that Israel started the fighting this time. And a spokesman in Tel Aviv says Israeli planes attacked Egyptian positions on the western side of the Suez Canal because of what he called Egypt's total disregard for the ceasefire line. A spokesman also said it was the first time the Israeli Air Force had attacked since the 1967 war. It is the Air Force on which Israel depends primarily for its defense. A report on that tonight from ABC's Russell Jones in Israel.
The Israeli Air Force, the spearhead of the Israeli attack, is getting an infusion of new blood. A class of air cadets is being inducted into active service. The Israeli armed forces are the nation's elite, and the Air Force is the cream of the cream. These young men are the survivors of training so rigorous that 80 to 90% of the cadets fail to pass. They are greeted by General the Minister of Defense and the hero of both the 1956 and the 1967 wars. The highlight of the show are aerobatics by Fuga trainers, one of the few planes the Israelis permit anyone to get a close look at. The French-made Mirages, Israel's best warplanes, flashed by so fast they were difficult to see. The demonstration of firepower lasted 2 minutes and included napalm, something the Israelis only recently admit they have used. The troop-carrying helicopters are the same type the Israelis are reported to have used on raids deep into Egypt, but the security-conscious Israelis have never even admitted they used any kind of helicopter on the sorties. Much publicized but little seen except by the enemy, this is one of the few occasions the Israeli Air Force puts itself on display. Russell Jones, ABC News, on an Israeli air base.
There is still, of course, a war in Vietnam. Despite rocket and mortar attacks in the last 24 hours, the situation there is considered to be a continuation of what military spokesmen call a lull. And preparations are going ahead for the withdrawal of the balance of the 25,000 American troops that are to be out of Vietnam by the end of August. But turning control back to the South Vietnamese is not a simple matter, as ABC's Ted Koppel explains tonight in this report from a Special Forces camp in the Mekong Delta.
This Special Forces camp faces as much danger from within as from outside its perimeter. There are 6 companies of Vietnamese and Cambodians assigned to the camp with their families. There are also 12 U.S. Special Forces advisors. Several months ago, counterintelligence uncovered a plot to take the camp from inside. The U.S. Special Forces commander requested that a lie detector team be flown in. The next morning, 55 of the Vietnamese attached to the camp were missing and were never seen again. Counterintelligence has since reported another plan to take the camp from inside. This one is expected to coincide with a military assault from outside. Special Forces has pinpointed several suspects. High on the list are 2 girls who work in the team house kitchen, the father of one of the girls who is camp carpenter, and the uncle of the second girl who is camp mason. Far from being unusual, this kind of situation exists in most U.S. Special Forces camps. The American commander in this camp, Captain Brian McDonald, wants to gather more information before he makes his move. And so the Americans mount a special guard every night to keep an eye on their allies. This is Ted Koppel, ABC News, in the Special Forces camp at Ba Swai.
It is a case of watchful waiting in Paris, too, where the Vietnam peace talks appear to have entered a new lull of their own. The North Vietnamese have turned down the latest South Vietnamese proposals on elections, but of course haven't come up with anything new on their part. Allied sources indicate nothing much can be expected to happen in Paris until after President Nixon's forthcoming Asian trip. But perhaps there may be developments in Washington after General Wheeler, the chairman of the Joint Chief of Staff, reports to President Nixon on his just completed tour of Vietnam. That report tonight from ABC's Sam Donaldson.
General Wheeler is expected to return from South Vietnam on Tuesday, bringing with him his first-hand impression of what meaning, if any, can be read into the current lull in the ground fighting. If it's read as a deliberate communist peace move, the president may be under great pressure to reciprocate, possibly by announcing a heavier second-step American troop withdrawal. While the White House mulls that over, the Senate will continue debate on the ABM, with no final vote anytime soon. Senator Mansfield thinks the vote may not come until September. But with the delicate Senate strength apparently shifted in favor of the president's safeguard ABM proposal. On taxes, Mansfield and the Democratic leadership remain firmly opposed to Senate consideration of the House-passed surtax extension bill until tax reform is coupled to it. Republicans will spend the week trying to argue Mansfield out of this position by saying that each day's delay imperils the economy. But all this activity will have to go on without the city's chief resident. President Nixon attends the All-Star game at Kennedy Stadium Tuesday evening, then leaves immediately on his round-the-world trip. Sam Donaldson, ABC News, Washington.
Those Soviet warships that steamed down the U.S. coast and parked for a while off Cape Kennedy arrived today in Havana Harbor. Thousands of Cubans lined the shore, many of them waving Soviet flags. A hearing for Senator Edward Kennedy will be held in Edgartown, Massachusetts tomorrow. The senator may be charged after that hearing with leaving the scene of an accident. A car he was driving, as you'll remember, plunged off a bridge around midnight on Friday, killing a woman passenger. Senator Kennedy, reportedly in a state of shock, did not report the accident until some hours later. He said he had tried to rescue the woman but failed. The county clerk, tomorrow, must decide if the evidence warrants serving a summons on Senator Kennedy. In Washington, Democratic leader Mike Mansfield said it could have happened to anyone. Mr. Kennedy has my full confidence. Explorer Thor Heyerdahl is scheduled to arrive at the Caribbean island of Barbados tomorrow. He was forced to give up his planned voyage in a papyrus boat from Africa to Central America. Sharks prevented the crew from repairing the storm-damaged vessel, so the sailors went aboard an accompanying yacht. Heyerdahl, in a message today to U Thant at the United Nations, said that space-age man has too much in common to be separated by political blocks or racial barriers. In Major League Baseball today, the National League, St. Louis at Pittsburgh, and the Houston doubleheader at Cincinnati were canceled by rain. The Eastern Division leader Chicago beat Philadelphia 1-0 in the opening of a twin bill. And Montreal beat the New York Mets 3-2 in the first of their two games. Atlanta trumped San Diego 10-0. In the American League, it was Kansas City 8, Chicago 6 in their opener. Detroit beat Cleveland 3-2 in their first game. The New York Yankees beat Washington 3-2 in 11 innings. It was Boston 6 and Baltimore 5. California and Oakland are playing on the West Coast, as are Minneapolis and Seattle. That is the news of this planet this evening. Coming up, of course, more coverage of the flight and the moon exploits of Apollo 11. This is Peter Jennings in New York. Now back to Frank Reynolds.
Howard K. Smith is in our Washington studios, and he has some thoughts on this moment in our history. So let's go to Washington now and Howard Smith.
I'm told that there have been sporadic protests from television viewers at not being able to see their usual and favorite television programs this weekend, and there will probably be more complaints later on. I beg to suggest to complainants that they're seeing what television is really for. Too often we consider this medium just another method of watching movies and seeing what used to be called vaudeville without having the trouble of going to the theater. But its real value is to make people participants in ongoing experiences. Real life is vastly more exciting than synthetic life, and this is real-life drama with audience participation. When John Kennedy was assassinated, the nation was overripe for a burst of divisive bitterness. There's no doubt that by being made participants in that tragedy, Americans were purged of bitterness, and television was the cause of that. What the outcome of this participation of hundreds of millions of humans in an otherwise unbelievable human experience will be, we don't know. But as one newspaper commentator said today, we can be sure that things will not be the same again. There's one consolation for television viewers of this event. Reporters who go to political conventions have discovered that if they stayed home and watched television, they would find out more than by going to the convention. Well, you're watching on television and seeing things that one very important figure is not able to witness. He's Michael Collins, circling the moon, nearer than anybody else to the landing except the men who have landed. And he has been witnessing less than you. He doesn't have a TV receiver in his module, and you've got one in your home.
The dead men reached the moon. It's been 2 hours, 18 minutes, 2 hours and 19 minutes, precisely as of now, since Eagle, the lunar module with Neil Armstrong as spacecraft commander and Buzz Aldrin as the lunar module pilot, set down on the moon in the Sea of Tranquility at a new place on the lunar landscape, now christened Tranquility Base. All has gone well. They have completed all their emergency liftoff checklist items and have been given the go to stay on the moon so far for the full length of their projected 21-hour and 27-minute lunar stay time. What's happening now up there is that at this point, Armstrong and Aldrin are scheduled to, and we have every reason to think they are, eating dinner like millions of other Americans. So, who can imagine any more unusual place for two Americans to have dinner than on the moon at this point? They've also been given the go by Apollo Control in Houston after eating to rest, then to begin their moonwalk at about 9 p.m. Eastern Daylight Time tonight. In an unusual reversal of procedures, a maneuver that was hinted at by Colonel Frank Borman about an hour or so in an interview with us here on ABC. Now here is Neil Armstrong, a tape playback of Neil Armstrong asking for the approval of Mission Control to begin the moonwalk early.
Quality over. Roger. Our recommendation at this point is planning an EVA with your concurrence starting at about 8 o'clock this evening Houston time. That is about 3 hours from now. Stand by. Well, we'll give you some time to think about that. Tranquility Base, Houston, we thought about it. We will support it. We're go at that time, over. All right, Roger.
So that took care of that, and they have decided now to go ahead and have their EVA, their moonwalk, in, probably less than 3 hours from now. There has been, well, the definite times have not been decided because, as Jules just pointed out, Houston has told them that they want them to rest after having their dinner or their lunch or their breakfast or whatever it is, but their food anyway in moon time. And then, after resting, they will break the hatch and decide to come out and walk in prime time, so to speak. It's very good. By the way, Jules, you talked about them eating. While Peter Jennings was giving the news, we had AOS here. You know what AOS is?
No, Frank. What is AOS?
Acquisition of steak.
Very good. Very good. You want to bet on that, too?
Food was delivered here.
Very good.
Magnificent sight out here. Magnificent desolation.